So let me give an introduction. So I have known Jay since 1992 when I was a programmer at NCAR in Boulder. And Jay was a postdoc with Dave Schimmel. And then we've been just through the universe stuck to each other here and there as we've gone along. Jay went on to be a professor at the University of Texas, and then ultimately UC Irvine, and then I moved to JPL in 2010, and we were in need of a water cycle lead, and we went out and recruited Jay.
I will never forgive you for that.
I know, I'm sorry, and then he became the Canada Chair 150 and the director of the Global Water,
something
for Water Security at the University of Saskatchewan. And we have some Saskatooners here in the crowd.
Okay, great.
And now,
Howdy.
as Jay announced, he's moving to Arizona State University, and he's going
Moved. I'm moving the house, but I already moved. The job started in January.
So he is a global futures professor in the School of Sustainability.
And that means I'm all knowing.
So those are the specs on Jay, but Jay has provided a lot of vision and a lot of amazing science, and continues to do so today. And the other thing is, some of you may have seen Jay's opinion pieces in the LA Times, and he lays it out there, which is awesome. It's not always awesome for Jay when he was at JPL, but it's awesome nevertheless. And so we're really lucky to have Jay talk to us today. So Jay, take it away.
Okay, I'm going to try to share my screen. Oh, it's looking good. And let's do slideshow. All right, does it look okay? I'm going to assume yes. I don't see Tom up in front waving his arms. Okay, so the title of the talk is Western Water Security Implications for Remote Sensing. And those of you who know me know that I've spent a big chunk of my career working with the GRACE mission. And so I will start off with some of our most recent stuff, which I find a little bit alarming, and then the global picture, and then sort of drill down. I really have done a lot of work on groundwater, so talk about that. But make the links to snow, because without snow melt, there's no groundwater, and the two, I think, reservoirs share a lot in common. One is the biggest thing, I think, is that we don't know how much we have of either of them. And so I think, with respect to snow and ASO are in much better shape than with groundwater, where, you pretty much have to go drill a whole bunch of wells to figure it out. Okay, so some recent global stuff. So I won't really go into the gray stuff. I think most people probably know it, but you may not know that we've been working on it since about 1996, 1997 with my first PhD student, Matt Rodell. And we continue to work on it. And really what we're measuring is time variable gravity driven by water storage movements over, it could be groundwater depletion, could be huge snowstorms and snowpack in the mountains. We see the change, not the absolute amount. And if we want to focus on something like snow or focus on something like groundwater, we need other data. And so another connection with ASO. And of course, it's very low resolution. And so that's another reason why we need ASO and other satellites to do the downscaling. I'll show a recent slide on that. This was the launch of the GRACE follow-on in 2018. I think I was still at JPL at that time, and it was really cool to go and experience that, and literally feel the vibrations and all that stuff. So a lot of emotion, really a really neat experience. Global picture, not great. Okay, when we think about where water is stored, we really only talk about three places. We talk about the ice sheets, the oceans, obviously, the ice sheets, Greenland and Antarctica, and the rest of the continents. And so the next couple of slides, when I'm talking about the continents, I'm talking about everything but Greenland and Antarctica. We don't really talk about, from a storage perspective, like a mass amount, and even a mass change. It's a very, very, very tiny. It's an insignificant amount compared to these other three reservoirs. Of course, critically important for climate and weather. And so this is the latest. It's not good news. Let me break it down for you. We got the ocean mass increasing. This is over the time period of Grace, so going back to 2002. And then we've got Antarctica in orange and Greenland in this sort of pink color, and the land. And this is maybe the first time that the land trend is bigger than that of the ice sheets in terms of contributions to sea level rise. So we've been calling this whole thing continental drying and working on a paper. And so, here's the big picture, and then we kind of break it down into spatially, and I'll show you some of that. So, we can kind of look at the trends here. So here's the increase in ocean mass, and here's Greenland, here's Antarctica, and here's the land. And so we can break down what's happening on land. And here's the glaciers and ice caps, so alpine glaciers and, Alaska, Patagonia, of course, lots happening up there in Nunavut, Canada. And the drying, which is, I hadn't really thought about it before, but I'll elaborate on it when I get to the spatial picture. So it's drought, it's groundwater depletion, included in there. And it's probably also snow melt. I hadn't really thought about it until now, but that will become more obvious in just a second. And here's the land trend. So these are the places that are getting wetter. One of the things that we have found in this paper, we did a paper in 2016, and Tom, you of course know JT Rager. And so JT led the paper in 2016. It was sort of a similar paper looking at sea level rise. We saw, of course, that the wet areas are getting wetter and the dry areas are getting drier, and had this plot with the trends. But now what we found is over since that time, since that paper, the dry areas are getting drier faster. The trend in the dry areas has increased. The wet areas are still getting wetter, but not at the same rate, at a lower rate. So that that figure from 20, I don't have the new figure, or I would show it to you. But that's a slowdown, and just in thinking about in the last half hour, thinking about the slides that I was going to show, I actually started thinking about the connection to just snow. Here we tried to break down, how much of the drying part, how much of this drying part is groundwater, and everything else. So increasing drought, and we're still working on that. So hopefully this paper will come out this fall. So here's the global trend map. So now we're looking at a couple of decades of Grace data, and the reds are the drying trends, and the blues are the wetting trends. And so we can just walk through some of these. So the ice sheets are melting away. They would throw off the color scale, so we sort of leave it off. But then here's the glaciers and ice caps melting away. So you see them here, Alaska and Peru and Patagonia. Now we've got kind of a climate signal: high latitude precipitation increase, and low latitude precipitation increase, and mid latitude drying. And this is what I was just mentioning. Over the last 5 years, we've seen this really big high latitude increase in melting and drying, and there's probably snowpack implications, which I didn't really think too much about until right now. And so, I'll finish up with a whole bunch of bullet points on why I think this is important for snow. But obviously, stuff's happening there that is really, really relevant to snow measurements or the lack thereof, and therefore the importance of missions like ASO. Tom doesn't pay me to be on the ASO bandwagon. I just am as a hydrologist. So the flooding is starting to really show up, and drought as well. And another thing that's really changed over the last 5 years is this European drought, and man, has it really come on strong. So 5 years ago, this was mostly like bluish or not much of a trend. So this has been pretty bad. And of course, when we talk about the southwestern drought, we never talk about Mexico, but like this is a southwestern North American mega drought. It's a big deal. And groundwater, of course, I'm never going to get off the groundwater thing, and I can't because you know people need to understand, especially now that I'm in Arizona. Worse, I would say that. Well, I'll save that for later. But critically important, really, when it comes to desert cities, groundwater, the disappearance of groundwater is really literally an existential threat. And so I'll elaborate that, which I've thought about before, but now that I live in the Phoenix area, really experiencing it and really feel the urgency and the need to really engage. And the last bullet point I put, which while you were talking, Tom, was that we really need to make ASO a formal partner in this Arizona Water Innovation Initiative. And we can talk about that later. So if we take this map and we map it to the major aquifers, get a map like this, and it really shows that over or almost half of it used to be over half, but right around half of the world's major aquifers are being rapidly depleted, and we don't even have the small stuff on here. So this this groundwater picture is pretty bad. Okay, so let's just talk about some regional studies of groundwater depletion and implications for the western U.S. and really around the world. So Grace gives us the change. Grace tells us the change in all of this. So this could be any pick any basin, and these days with downscaling we're able to get down to about 50,000 square kilometers. So still very very large basins. But once we combine with other data like ASO data or other data on the ground or models, we're starting to downscale to, I don't know, might be about a quarter degree. So we're really getting down there. So anyway, Grace sees all of this, the surface water, and the snow and the surface water and soil moisture and groundwater, and it's the delta. So that we know that the total change is the change in the components. And so if we want to do groundwater, we can rearrange, right? And people have actually, and so we get so you want to look at groundwater storage changes, then we get this from Grace. Hey, you know what? We can use ASO. We have been using SNODAS for a long time in California anyway. Change in surface water observations. Hopefully one day we can do this all. I should have put in my old JPL slide where I show like, hey, we're going to use ASO or maybe a future snow mission. And for this, we're going to use SWAT, and for soil moisture, we're going to use SMAP, and we're going to solve the world's problems. We're not quite there yet. So anyway, if we want to look at change in storage on land to isolate the groundwater, if we want to isolate the groundwater, we take the delta S from Grace and we remove that. And by the way, people have estimated there's papers on snowpack from Grace and P minus E. So you can play with these terms in different ways. These case studies, I show these because, and I have a slide, I think I have a slide a little bit further in, that none of this stuff is changing. So these are some of the first big papers that we wrote on India and California and the Middle East, and the time series here showing the long-term decline. And these are just images from some animations that we used to do at JPL. And I've seen your animations and Tom, and those sort of animations are just, as well as some of the beautiful photography that's been in some of the major papers, are incredibly important. That's really this deep red color just scares the crap out of people, and just like those beautiful images, the photography, Tom, that we've seen of some of the ASO flights, just beautiful stuff, and really, sort of gets to people on an emotional level, which I think is important because, like, we got to figure out what works, and so anything goes. Oh yeah. Okay. So here, right. So I just want to show, like, okay, we wrote this paper in 2009. I mean, shit, man, it's just like just continues to decline. California. I'll show you our update just a second. Punchline, getting worse. Middle East paper 2013. Just continues to decline. Lower Colorado. Now I live there, and the time series doesn't really look that much different. It's just now that I look at this one. Um, the updated one pretty much looks the same. Sort of goes up in the beginning and then starts this drop. So none of that's good news. Here's an update to the California paper. Published this just before Christmas and just before the beginning of the very wet season, right? And so people want to know, like, hey, is everything solved? And of course not. So what we're looking at is the long-term disappearance, cumulative groundwater storage changes in the Central Valley going back to 1960. Red is the USGS from the Central Valley hydrological model, which has been calibrated with a bunch of wells. So really, sort of rock solid. And here's the gray stuff that's tacked onto the end there, that, update through the 2022. Actually, we updated again. It's more of the same. Colors in the background represent whether it's a really dry period like this dark tan, or wet period like this dark blue, or moderately dry like tan, or moderately wet light blue. So overall decline. We do have the Sustainable Groundwater Management Act, but it hasn't really been fully implemented. And the other thing is that we really only get a little bit of increase in these wet periods, and then a big decline. And all the more reason why, the connection to ASO, you may be wondering why Jay keep talking about groundwater. Well, groundwater is super important for the southwestern United States and for food production. But the links to snow are not, they're obvious to you, but they're not obvious to the rest of the world. And so really capturing all that recharge during these, first, it's never enough, right? Because we use too much water, but capturing really understanding how much we have there in the mountains, and how, the timing, right? Using ASO to understand the timing of the snow melt and the runoff, and what we can do to capture it. It's just so critically important. I know I'm preaching to the choir, but it feels good. Colorado River Basin. We did this paper in 2014. I'm updating it now. And so here's the trend in the total water storage. So the ups and downs, the seasonal, wet season, dry season, and you can kind of see the trend there. And when we wrote this paper, we were like very sort of concerned about the lack of attention to groundwater, especially in the lower basin, which is where I live now in Arizona, mostly Arizona. The lack of attention to groundwater. And of course, it's important to look at Lake Powell and Lake Mead, but just like there's a ton of snow up there in the mountains. And no one knows, really what's going on. It's the same thing with groundwater. And so this paper showed that sure, Lake Powell, Lake Mead, at this point in time are really, declining. And this graph more or less still holds true. But what was happening with the groundwater is that, like, since it's like unmanaged, it's disappearing. It mostly unmanaged in Arizona. About 25% of the area is managed. The rest is the usual groundwater free fall. So the groundwater is disappearing about 6 or 7 to 1. Okay, so here's some updates. Won't really get into it because we're just, these are pretty fresh results. But that's that time series that I told you about that sort of, the scale was different on the last figure. It was basically the same time series, a little increase in the first few years, and then this big decrease. And here's what it looks sort of spatially, in these time periods. You can really see this pronounced drying in these regions where, this is where like a lot of people live. This is where there's lots of agriculture. And so, it continues. And right, this must be when we wrote the paper. So, what are we trying to do now? So we've got GRACE data, and I don't know what resolution that is. Maybe that, I'm not even sure. But maybe it's 1/4 degree. But we have much better ground-based observations than we've had before, that I've had access to before. And this is from our colleagues at ASU, Kyle Center. And these may be USGS data or Arizona Department of Water Resource data, but like they put this is called the Arizona Water Blueprint. So if you never looked at it, you should take a look. So, great opportunity. So right now, making maps for validation or for calibration, maybe we'll do some machine learning stuff. But, here's where ASO and the other satellites really, and remote sensing, really come in. So we really need to use this top one as SMAP, right? And the second one is EcoStress. The third one is SWAT. There's ASO. And I didn't just put this in here, although it is at the bottom. I didn't just put this in here today. This has been in here since I made this slide, which I think I made it last month. And so now we're able to really, what do we want to do? We want to do this everywhere, but let's take Arizona because I live there. So we want to produce these best available maps for different templates. Maybe it's counties, maybe it's river basins, maybe it's groundwater sub-basins. Those blue lines are some of the managed areas. So you can see it's not a very big, not big by area. And you can see underneath there, that's the underlying resolution that we're at right now. And so we want to keep pushing it forward to really sort of advance what we could do. And it's kind of an all hands on deck thing. Talking about the Southwest. Okay, so just made a plot here. Just went to the JPL Grace data visualizer. And, it just doesn't look good. In a lot of, when you look in the Southwest, you definitely see the sort of same shape in all different states across the Southwestern US, Canada, Arizona, New Mexico, and even, in West Texas. About half of Colorado looks like this. So challenges ahead for all of us. I would like to say that the rapid pace and global scale, it's not only groundwater, I mean, it's freshwater availability is changing, has far outstripped the pace and the scale of society's collective response. And that includes our measurements, and that includes our policy, and that includes our technological developments, and almost every place that we every rock we pick up, realize that the things are not moving fast enough. I want to finish up by talking about, again, preaching to the choir, but maybe there'll be some nuggets in here for why I think this is important. I know you folks already know, but maybe I'll throw in a couple of extra bullet points. Maybe you can extract an extra bullet point for your own use. So we don't know how much snow is up there. Tom's been saying it for the longest time. I say the same thing about groundwater. When you think about what fraction that is of like the water storage, it's like most of it. And we're only just starting to get a handle on our surface water and our soil moisture. So that's problematic. I mean, it's not just for water supply, and of course for flooding and water management, of course, and reservoir management. But just to tie it to this talk, in the western and especially the southwestern United States, the groundwater recharge, that's a really, really tough thing to measure. And so the more you are able to capture that and understand that rate of snowmelt and where that water's going, the better job we can do estimating groundwater recharge, and also doing things like managed aquifer recharge, that episodic recharge. Now, the episodic nature of whether it's hot spells or cold spells, the periodicity is really, really important. And it's so important for flooding, but also very important for groundwater recharge. Across the West, and so, I've lived in California for a long time, and now in Arizona, of course we need our snow. And this is true up here in Saskatchewan. The rivers are actually super low right now. The Saskatchewan River. Right, so that snow feeds our rivers. But maybe one thing that I don't know how much you folks think about this, but the disappearance of that snow and the shorter snow seasons and the smaller amounts of snowmelt and the decreasing, where we do see stream flow decreasing, that puts incredible pressure on the groundwater. And that's exactly what's happening in Arizona. So we're anticipating the Colorado River cutbacks. Arizona is sort of, junior in terms of its water rights. And the pressure on groundwater is it's already picking up. And this is a problem because most of it's non-renewable. So the better we can estimate the water balance all across the West, but let's just talk about Arizona in this particular instance because there's a lot of focus and a lot of resources are being pumped in by the governor's office. So, and growth is being curtailed, and active discussions about ramping up the Arizona Groundwater Management Act. So the disappearance of that snow melt and river water has huge implications, of course, for groundwater. The drying that I showed in Canada and Northern Eurasia, that's pretty huge. And so, the degree to which there's disappearing snowpack up there, which is probably quite large, and the change in the snow season has huge implications in the north. Oh, sorry, I'm not like sort of flipping through here. Sorry. Okay, I wouldn't just ramble down forever. Okay, so that high latitude melting and that water loss has huge cultural and livelihood impacts, especially in our indigenous communities. When you go up there in northern Canada, there's just like nothing. Indigenous communities and the northern lights and polar bears and tundra. So, but it's melting and it's disappearing, and so it's quantification. That the rate of change and getting that message across, like collecting the data and showing what's happening is really, really important. Another thing, I know you think about fire frequency, but I don't know how much you thought about Canada. And let me tell you, it's become part of the climatology up here now. So in the 5 years that I've been here, the smoke season has got worse and worse. I would say 50% of the days now are covered by smoke in the summer. And it's that drying, it's the increasing fire frequency. And so the accelerated melting, of course, you're in with your hyperspectral and your albedo measurements, and with your lidar measurements, you're just in a perfect position. And of course, I know Tom's done great work here, but just with respect to Canada and that sort of feedback between the rapid melting that's happened over the last 5 years, the increasing fire frequency, and then the feedback because of the smoke, right, on the ash on the snow is pretty scary. And of course, those smoke plumes, it's funny, in Canada, we just sort of accept it like Canada's like, yeah, whatever. But like, you go to New York. I was in New York when that Canadian smoke came down there. And man, it was like, everyone was masked up. It looked it was kind of reminiscent of 9/11, actually. So this is sort of spreading all over the world. So listen, I think again, Tom doesn't pay me to say this. I think it's true. Like, we can wait around for a snow mission, and we waited. Like, I can't even tell you how long we waited for a soil moisture mission. It started in the 70s, right? And that was 45 years before it launched in 2015. So we can wait around. I hope things are moving along. I know there was some stuff going on in Canada with some of our colleagues who may be in the audience. And I haven't really followed. I know the snow mission was ranked highly in the decadal survey, but who the hell knows? And the missions are super, super competitive. And, we've got something like ASO, and you've got the problems that we were talking about. Really existential threats to the way of life in the Western United States, and that, of course, includes the economy. I think we need to expand it across North America. I think we need to reproduce it around the world. Okay, and this is the bullet point that I put in while you were talking, Tom. Like, I just realized, okay, we've got this Arizona Water Innovation Initiative. It's $40 million from the governor to go figure out, okay, well, like, how are we going to, what are our pathways to sustainability? What are we going to do? Well, of course, at my end, it's always going to be measurement, the monitoring, right? How much do we have? How much do we use? How is it changing over time? we're not, we have snow in Arizona, getting out there with doing this traditional snow surveys isn't going to do the job. So every drop really, really counts. I think I'm done. So yeah, I mean, you just Google the Water Initiative. Hey, I do a podcast. We're going to have Tom on there. Tom has promised to get me on the plane, and we're going to do an episode about ASO, but just some other stuff that easy reading, a map of the future water, all kinds of video stuff, and Twitter and LinkedIn, and that's it, man.
Jay, that was awesome. Thank you. I just wish you were here in the room so you could see everybody.
It would be great. I wish, it was my plan. But then when I agreed to do this, we hadn't sold our house yet. So I thought, all right, we're never going to sell the damn house. So sure, I'll come there. But then we sold it, and the movers are there.
Well, we're looking forward to having you on the plane and doing
that. Would be really, really cool.
Yeah, but that means you have to be trained, and you have to know how to operate one of the instruments, right, Liz?
Yeah. Okay. How about parachute, just in case?
So, all right. Questions, comments? Yep.
Hi, Jay. Baxter View here, and I wanted to ask you a question. And your maps and the colors stimulated a lot of intellectual curiosity in me. So in the Southwest, there's red and depletion, and in the central United States and to the east, there actually is an increase.
Yeah.
And so I guess looking at your general depletion curves, though, for the land-based moisture and the increase in the sea level rise, I think there's another reservoir. I was trying to stack those up and see if it accounted for everything. And what about the atmosphere? And so with the Clausius Capron, we expect a 7% increase in water vapor stored in the atmosphere. And I wonder if you've linked that or
we have. Yeah. So I said at the beginning, but maybe it didn't make sense without without the other charts. The atmospheric storage, so of course, right? I mean, atmospheric water is incredibly important for climate and climate change. But in terms of water storage, it's actually really, really tiny. So it's like a flat line on those figures.
Okay, thank you.
Sure.
Hey Jay, great presentation. It was really cool to see your work. I've always heard about GRACE, and actually seeing the data was pretty neat. I come from a water management background, and I'm really interested in your perspective of what is your role as an academic in the policy world, in the water management world. Yesterday during our discussion, the panel discussion, it was a topic that was brought up, and just you seem more motivated to plug into the policy world. So how do you see your role, and how do you see you fitting into the world of water management and policy generation?
That's an excellent question. And I struggle to answer it. I think I have a role in doing the science, and of course in training future scientists, but putting out the best available science, and then communicating it, and without really advocating. And so people can argue, if I write something in an opinion piece that says, hey, we should think about conservation, or like, hey, we looked at the data, not really sure about if the Sustainable Groundwater Management Act is going to be fast enough. Those are science driven. So I guess the answer is, I think I have a big role, but the biggest role is doing the science. It's not like, the world needs another mouthpiece. What the world needs is people who are doing the science, and it's peer-reviewed science. And when there are compelling results, that we make the effort that we need to make to share that information. And it could be with water managers, it could be with state legislatures, and it should be all of the above, right? Our U.S. Congressional members, and in my case, Tom mentioned the opinion pieces, and all of the various documentary, media stuff that I've done. That's the general public. So, but it's all science driven, right? It's not just like me telling a story about water. It comes from the responsibility that I feel to communicate, to tell it. Tom said it, like, you got to tell it like it is.
Yeah, I'll just add to that science is successful as a time integral. So sometimes we get results that are important and they're right, and sometimes we get them wrong. But ultimately, the time integral is what leads us to that better understanding. But at times, that time integral requires a far greater duration than what we're up against, and so at times we need to punctuate it with the results and really push them out there.
Yeah, but that's a really good point. We can't really sort of sit back, not with water, right? We can't really sit back. I think we do need to take a page out of the carbon notebook. And I've written a little stuff on this called like water is the new carbon. Not that like, water vapor is, like not like CO2 is not important. It's more like, hey, you know what? Like, the carbon community has done a great job with carbon accounting and pushing the whole net zero thing, and so we may need a little bit of that to sort of crank up the energy level and the focus.
Jay, I'm going to insert myself here with a question. The drought in the Middle East and in particular Syria, my recollection was that that really helped to exacerbate and even catalyze the civil war. Can you talk about that?
Yeah, I mean, I think any time we've got these hotspots in places around the world that might be more vulnerable, or if the government isn't really committed to water security, then people get pissed, and that's basically what happened in Syria. Is that there really wasn't a commitment to get water to the farmers. Many of whom were, on the young side. And so the water wasn't there. And so they, basically gave up and they moved to the city, and they were pissed off. And, then that's when you get a bunch of young people flocking to the city and are upset. When people don't have food and don't have water, think about you. I've been around you, Tom, when you're hungry or thirsty. You're like a freaking bear. So just imagine, right? Thousands of young, whatever farmers not having access to water, have their livelihoods shot. So I didn't make that up. I mean, that's sort of an established narrative.
Yeah, and the trends that we've seen. So the drought that we saw in 2012 to 2015 here, and then punctuated further by intense drought years, and we saw some of the perimeter communities in the Central Valley having to truck water in simply to wash their hands and cook their food. And I think they were, I don't want to say lucky, but some of that was stemmed by 2017, 2019, 2023. But those kinds of years cannot necessarily be relied upon, nor do they give us everything that we need.
No, and I agree. I just want to say, like, people always saw, all the, you probably got similar calls, Tom. You get calls from the media like, hey, like, is everything going to be okay? And like, then I show them that long-term graph from 1962, right, up to the present. Like, no, it's not going to be okay, right? But that's part of our role too, is making sure people understand, like, okay, we had a really wet winter, but the size of the the hole when it comes to groundwater is unfillable.
Jay, my name is Evan.
Yeah.
Or just I used to do some grace work, so this is
Cool.
a cool talk. It's cool to really see. I was totally oblivious to the magnitude of the mass loss from non-glaciers. That was really cool to see. I'm curious if now that for the Central Valley, now that you have this really good picture of mass losses in the Central Valley, if anyone has done kind of a thought experiment and said, if we were able to capture all of the runoff from these big years like we just had,
Yeah.
are we
Yeah.
in the same order of magnitude, or like how close are we to the mass loss rate that you're seeing in the Central Valley?
Yeah, I think. Look, I mean, I think the governor at some point. Sorry, wrote an opinion piece, but I don't remember what I put in it. But after that paper came out, and I forgot what they're like. There's a deficit there, and so if you want to stem that trend, and the trend is whatever it is, I forgot what it is, but like whatever, however many cubic kilometers per year. Well, you have to replace it, and so that is. People are at, the governor, I think Newsom made some kind of commitment to it. So yeah, I think the state Water Resources Control Board, I'm sure, plenty of our colleagues are out there doing this kind of stuff, absolutely thinking about it. And then also thinking about where do you do the recharge? Where are the best places? So Rosemary Knight's doing a lot of work on doing these EM surveys, helicopter EM surveys, trying to find the best places. So, it's happening. I think it's we're not going to fill the basin back up. But look, I think the goal should be, I'd love to see just those trends disappear. It's not clear to me if we can make those trends disappear and still do the agricultural production at the same rate. So, it's kind of a moving target. That's a long way to say, yes, people are looking at that. And a lot of people.
Hi, Jay. It's Ronnie Rosenzweig from NCAR, and thanks for taking the time this morning in your very busy morning to give this awesome presentation. My question is around some more of a global trend perspective as well. Looking at the GRACE data, there's a lot of conversation about the term acceleration of the water cycle. Instead of this all-encompassing variable, are you seeing an acceleration of the water cycle signals in the data that you're looking at?
So I'll give you a long answer and a short answer. The long answer is we actually wrote a paper on using the amplitude of the GRACE signal. So you can check it out. I forgot what it's called, seasonality of something. But Rishi Chandrapurkar was in GRL just a couple of years ago. So we actually look at the amplitude of the global signals and use that as a measure of the strengthening of the water cycle. And so the first time, when we first got the GRACE data, over the first few years, the amplitude kept getting bigger and bigger, wow, water cycle acceleration. And so we wrote a paper and it got rejected. And anyway, then we sat on the data and then things leveled off and then sort of slowed down. So I think what we are seeing is, over the last 20 years, we've seen that we can use the amplitude of the GRACE signal to track the changes in strength of the water cycle. And we've seen accelerations and we've seen decelerations. That said, I would say over the last 5 years, things are pretty much heating up. And Matt Rodell had a paper on the increasing extremes using GRACE data that came out, I don't know, sometime in the second half of last year. And then this stuff that we're showing about the just over the last few years, the changes at the European drought, but the bigger ones, the changes at high latitudes, those are all new. So, something's happening, and I'd say that things are strengthening at the moment. But I guess the bigger thing I wanted to say was we've seen ups and downs over the 20 years, not just pure acceleration.
Yeah, Steve Haugen with Kings River Water Association. One of your graphics showed increasing sea storage and decreasing dryness on the land surfaces. A lot of those dry areas border the oceans. Do we actually have enough resources to be able to do desalination and provide those waters, those coastal areas, to start to create some level of balance?
So again, two-part answer. The first part is, those global trends with more water, going into the ocean than ever before, contributing to sea level rise, actually suggest maybe we should keep more water on land. And so, desalination would be a part of that. Desal, it has its issues, which are, the usual, like energy intensive, and what do you do with the brine? And so, those are, expensive. So those are issues. And then there's a third issue or a fourth issue, which is, the governance of the oceans, right? Like, can everybody start doing desal around the world? And, is this a problem? And what's going to happen with the brines? And if you keep throwing them into the ocean, then you're going to destroy the coast. So I think we have a lot of issues there. That said, I think in certain, cities that are close to the coast, so, make the transport issues less onerous. I think it'd be an important part if we can solve some of those issues, including what to do with the brines and including the energy cost and overall cost. Then I think it's going to be an important part of at least of urban, right, metropolitan water supplies.
Jay, thank you. I vowed this morning that we were going to try to stay on time, and you did perfectly.
Awesome, man.
I can say
That's
about
been great.
myself from Monday, I took way too long talking. So, thank you. Let's talk soon. We'll be happy to join.
Okay.
You. And then I'll send you. I was going to ask you about the PDO. Mike Anderson is thinking that we're going to be coming out of this protracted negative phase we've been in, and I wonder.
Okay. Yeah, let's talk about it. Yeah.
All right.
All right.
Thank you.
All right. Okay. Bye, everybody.
Awesome. So today we've got a couple sessions focusing on the Colorado ASO program. Since we're in California here, I figured I'd show a map of Colorado and where the ASO basins are. This year, we've had some good expansion activities, expanding the areas that are ready to go with snow-free data, as well as snow-on surveys this year. Snow-ons were in the blue, and on this map, and we fortunately have folks from all of these basins to talk to us today about this year's activities. Erik, if you'll hit the clicker. We've got, this morning, Erik's gonna lead us off. Erik is the Special Projects Coordinator with the Interstate, Federal, and Water Information Section of the Colorado Water Conservation Board. Erik's been a great partner over the years shepherding this statewide ASO program in Colorado. And then this morning's session, we'll have Emily Carbone from Northern Water, Scott Griebling from St. Vrain Lefthand, and Nathan Elder from Denver Water. So kind of starting in the north for the morning session, and then we'll hit the other basins in the afternoon. So Erik's going to lead us off and talk about the statewide program and the CASM group, Colorado Airborne Snow Measurement Program, which is really a stakeholder-driven effort to expand and sustain the ASO program in Colorado. Erik, let it rip.
Awesome. Thank you, Jeff. And before I get into the presentation real quick, just wanted to say hi to everybody. I really am sorry that I couldn't make it. Unfortunately, the state still hasn't quite figured out our travel budgets post-COVID, but I really wish I were there, and I'm sorry to miss you all today. So I'm here just to really set the stage for today's speakers and get to chat about the Colorado program and sort of give you a brief history. Now, last year I did a more in-depth history on the CASM group. So this year we're going with the history of CASM part 2, the update. Just a quick recap of what we talked about last year. So CASM really started as a really kind of a piecemeal, everyone doing their own kind of thing kind of effort. CWCB had been working with NASA and JPL using ASO as kind of a spaghetti at the wall approach to close some data gaps and figure out some streamflow forecasting solutions for our local stakeholders. And it wasn't really until 2021 when Denver Water and a group of other locals came together with a statewide feasibility study. And when I say the Colorado Airborne Snow Measurement Group is a grassroots, stakeholder-driven effort, I really, really mean it. This statewide effort would not have happened without these folks coming together and applying for this grant to take a look at the statewide feasibility study. There has been substantial growth in this group since that initial formation. We have well over 100 plus stakeholders attending all of these CASM work group meetings to talk about ASO implementation, what's happened, how it's worked, how it hasn't worked, where we could possibly expand to next, all that good stuff. In 2022, this group was able to get 12 snow-on flights throughout Colorado and 6 snow-free flights. Now, like I said before, it was really a piecemeal scattered approach. We were maybe getting 4 to 6 flights a year, and that was just CWCB doing kind of a spotty situation, and then folks working on their own to get their own ASO data. And our planning team is really to thank for this. That's Northern Water, Denver Water, Colorado's River District, St. Vrain Lefthand, ASO, and Dolores Water. And a lot of these folks you're going to hear from today. So 2023, little update. The Colorado Water Conservation Board, the agency I work for, came up with an update to Colorado's water plan. And this is a statewide water policy and planning document. It lays out the needs and things that we can do to address concerns and issues throughout the state of Colorado. And part of that, and one thing I want you guys to really know, is that state of Colorado is facing a supply and demand gap. So these gaps are really looking at the municipal and industrial and the agricultural gaps throughout the state of Colorado. It ranges anywhere from 23,000 acre foot all the way up to 3.3 million acre feet. And that's just talking the direct beneficial use. We're not talking about environmental flows and all that good stuff. So on top of this gap, Colorado is also in a unique position of being the Headwaters state, right? All of our water that's not used in the state flows outwards. So we have our own internal uses that we got to be planning for and working out. And then we also have to worry about our interstate compacts and deliveries to the folks downstream of us. Y'all in California, of course, the upper basin delivers water from the Colorado River Basin to you all through Lee's Ferry in the Colorado River Basin. So all of this planning and all of these needs, both in the state and out of the state, and our main data source, as we've heard, has been the SNOTEL stations. And this is an outdated graphic. Of course, this is data from 2018, or 2019, excuse me. But the point I'm trying to make here is that we're really making all these decisions for the water use in state and water needs outside of the state based on these SNOTEL stations and this data that's available. Just to drive that point home, again, going back to that snake graph of how much water flows out of the state, all of these SNOTEL stations are what is the basic data source to figure out what's going to be flowing out of state and allow us to make all of these decisions. So I'm preaching to the choir when I say we can't plan for what we can't see, right? We're squinting at this tiny little data set to make all of these decisions. And that really was the driving point of the CASM group and this expansion effort. And so we have been expanding rapidly since this whole CASM group began in 2021. And last year was a pretty banner year for us. You're going to hear from all of these folks today, but we had 20 surveys in 2023. And again, to reiterate that expansion part, in 2022, we only had 12 snow-on. So that is a serious expansion of effort in trying to get this high resolution snow data throughout the state. Now, we definitely have more work to do. You'll see these pink basins here. They have current snow free, but don't have any snow on data. Now, on top of just collecting the data itself, we were experimenting with some different forecasting platforms. Now, I did cherry pick a couple of these just to demonstrate what's going on. So we've been using ASO as an experimental forecast with the CBRFC, and you're looking right now at Dolores, and that is this chart on the left-hand side here. And this kind of tealish color is what the CBRFC forecast was looking like with ASO data ingested. Now you can take a look, and that ASO ingestion actually helped narrow in on what the actual observed flow is going to be a little bit sooner than the official forecast. Again, this is experimental, and it was not used in any sort of official capacity. It was just kind of like a, let's take a look at what happens if. And we're also at the same time using Wharf Hydro with NCAR and Dave Gotchis. And that's what's happening over here on the right. And you can see this observed flow fits quite nicely into the 2023 traces that were, wow, my brain just died. But you get the point. The observed is following pretty closely to these 2023 Wharf Hydro traces. Now, again, I cherry picked these to demonstrate just how varied these results can be ingesting the ASO data into these modeling platforms. This is CBRFC at Taylor River, so this arrow pointing down here. And when we ingested ASO, it kind of undershot what the actual observed flow was going to be, and it turned out that the official forecast was a little bit closer. The Wharf Hydro was kind of similar. The observed flow was off. The traces were actually showing a little bit more flow than what actually occurred. So there's still a lot of work to be done as far as figuring out how to ingest this data into these different platforms and calibrate things accordingly. So what's coming up into the future? I talked about Colorado's water plan because CASM is specifically mentioned as an action item in that giant document. It talks about the need for spatially based data in order to make better decisions. And so CASM is a part of Colorado's water plan. And we're going to have more in-depth discussions of what a statewide program would look like at my CWCB board meetings. You'll be hearing from one of my board members later this afternoon. But that hasn't stopped my board from investing into this statewide program. In fiscal year 23-24, which just started back in July, the CWCB board invested $1 million towards this program. And we're currently trying to use that to leverage a Bureau of Reclamation funding opportunity. The phase 2 of that occurred back in August, so we still don't know the results, but there are a grand total of 5 folks that made it into that second phase of this granting process. So we're hoping to hear back soon. We also are going to be updating the Upper Rio Grande for some snow-free data, and then other items, of course, are going to be based on the outcome of that Bureau of Reclamation grant. There's also potential funding coming directly from the Upper Colorado River Commission. Now, the amount and timing of that is yet to be determined. However, there is investment outside of the state itself. So if you want to get involved, go to coloradosnow.org, send me an email, or Taylor Winchell at Denver Water, and of course, Jeff Deems from ASO. And with that, any questions?
Thanks, Erik. Any questions for Erik? Comments? Heckling? Our typical hecklers aren't here today. Tom.
Hey, Erik, thanks so much for that. This is Tom Painter. Looking at your background there, I'm reminded of a Frank Zappa album that was called Shut Up and Play Your Guitar. So I'm hoping that later this afternoon you'll play your guitar.
That might be arranged. We'll see.
Yeah, we keep threatening to do that in the CASM calls too, but we haven't yet achieved that.
Threaten is the appropriate word.
Microphone coming to you, Jean.
Yeah. Hi, Erik. This is Jean View. And could you put the slide back up that shows the pink basins that have had snow-free coverage, but no snow on?
Yes.
Thank you.
Is this the one you were wanting, or the one at the very beginning?
No,
It's still got the map, but
yeah, that's the one. Thanks.
perfect.
Jean, all the evolution of these maps is all in the CASM materials in the reports online as well, if you want a deeper dive. All right, thank you, Erik. Thanks for the overview.
Thank you.
And up next, we've got Emily Carbone, who's a water resources specialist for Northern Colorado Water Conservancy District. Hi, Emily. Good to see you. Wish you were here. And Emily's going to talk about Northern's operations with ASO in the Colorado Headwaters.
Thanks, Jeff. I wish I was there too. Let me share my screen quick. All right, let me know if you have any trouble seeing that. But I'll get started. Yeah, I'm Emily Carbone. I work at Northern Water. And so I'll be telling you about our experience so far with ASO flights in the Colorado Headwaters. So this flight area is shown in blue on the map here. It's the Colorado Headwaters upstream of Windy Gap Reservoir. Includes the Lake Granby inflow basin, the Willow Creek Reservoir inflow basin, and the Fraser basin. The Bureau of Reclamation facilities are shown in the blue triangles, and they're part of the Colorado Big Thompson project, with which Northern Water operates jointly with the Bureau of Reclamation, and it's a major water user in this area. In addition to the Colorado Big Thompson project, other water users in this flight area include the Windy Gap project, which is also operated by Northern Water, the Colorado River District, Denver Water, Grand County, and Middle Park. But for now, we'll focus on the Colorado Big Thompson, or CBT project, because that's Northern's primary interest in these ASO flights, and they're the primary water user in the Granby and Willow Creek basins. The CBT project delivers water from the Colorado Headwaters to the Northern Front Range across the Continental Divide through the Adams Tunnel. The service area is shaded in green here on this map. The project delivers water to over 1 million residents and over 600,000 acres of irrigated farmland in northeastern Colorado. And so together with the Bureau of Reclamation, Northern Water jointly operates and maintains and funds this federally owned project. The project is made up of 12 reservoirs, some on the west slope here and some on the east slope, and 35 miles of tunnels, 95 miles of canals, 6 hydroelectric power plants, and 700 miles of transmission lines. So there are countless critical operational decisions that need to be made to run this system. These are just some examples of decisions that need to be made at Northern throughout the snow and runoff seasons. First, reservoir operations, deciding whether and when to pump Windy Gap project water and water from Willow Creek Reservoir to avoid unnecessary pumping costs, but also to optimize the amount of water that can be provided to water users. Also deciding when to make preemptive releases to avoid flooding, and optimizing deliveries to the East Slope water users. Also optimizing power generation. We try to time our Adams Tunnel operations to optimize power generation at the power plants on the East Slope. And another big decision at Northern is setting the annual CBT quota. That's set at the April board meeting by our Northern Water board, and it determines how much water is allocated to each CBT user. The quota is based on West Slope supplies and East Slope demands. Setting the quota is a crucial balance between ensuring water users have the water they need in the current year and ensuring that the system storage remains sufficient for future years. Setting the quota in April is important for all of our users to be able to plan their operations for the water year. Municipalities need to decide whether to have watering restrictions, rent out water to ag, or pursue additional supplies. Ag users need to decide on their planting and pursue additional supplies if necessary, and things like that. So for all of these decisions, snowpack information and streamflow forecasts are essential to making these important decisions. With the increased variability and uncertainty due to climate and landscape changes, there are more and more uncertainties in our streamflow forecasting that make it increasingly difficult to predict runoff. So it's more and more important to constrain the uncertainties that we have the ability to constrain. So there are many different important factors that determine the runoff each year, but as our basins are snowmelt dominated, snow is generally the most significant predictor. Though we have known that snowpack data was essential and have been monitoring snowpack data for decades, we've been flying blind to some extent, using only a handful of SNOTEL stations to characterize entire basins. So SNOTEL stations provide an essential historical record, and they'll continue to be invaluable for the foreseeable future. But using them to characterize entire basins is not always accurate because there's so much area that we're missing. The map on the right here shows Northern's modeling zones in the project area, including the Granby, Willow Creek, and Fraser basins. The majority of the, and then the black dots here are the SNOTEL stations, and the majority of the SNOTEL stations here on the eastern side are actually on the other side of the divide and are not necessarily representative of conditions on the west side. So many of them can't be used to characterize the conditions in these west slope basins. So you can see there are very few stations actually within these basins, within each basin, and a few more outside of the basins that are close enough to be used to characterize the snowpack in the basins. But there are many areas in these basins and several of the modeling zones that aren't captured at all by the SNOTEL stations. The table in the middle here shows all of the SNOTEL stations that are used to characterize these three basins, from highest elevation at 11,300 feet to the lowest elevation at 8,720 feet. And the graph on the left shows the SWE volume distribution by elevation in the two flights that we had in these basins in 2023, in April in blue and in May in red here. And this black line shows the elevation of that highest SNOTEL station, Berthoud Summit, at 11,300 feet. So you can see that, especially in that May flight, almost half of the snow was above that maximum SNOTEL station. So there's a lot that wasn't captured. So due to these gaps in the available snow data, we've been eager to supplement it with ASO data. So at Northern, we've been able to get ASO surveys in these basins in 2022 and 2023 with the help of CASM, CWCB, and cost sharing with USGS, which funded the Fraser flights as part of their next generation water observing system. So we've had two flights each year, one targeting peak SWE in April and one in mid to late May. We've compared the peak SWE, we've compared the ASO data with other snow data and forecasts, and we've used the ASO data in combination with other snow and forecasting products to plan operations. The ASO data has also given us insight into the hydrology of our basins. We've been looking at the runoff efficiency and post-fire landscape and hydrology changes. We've also used the data for verification and improvement of other spatial snowpack data sets, which I think Graham Sexton will be talking about tomorrow. This is just an example of what the ASO data looks like in our basins. This was from 2023. This is the April flight, and you can see Winter Park in this image with the ski area and center left, and then the Berthoud Pass Highway showing to the left there. And that's the May flight. And then here are the some observations of what we've seen so far in ASO in the Colorado Headwaters. Again, we've had 2 years of ASO. Sorry about that. Yeah, we've just kind of started scratching the surface of what we can do with ASO in these basins, but I'll show you some of what we've found so far. We've been focused on the Granby and Willow Creek inflows for our analysis so far, though we were also interested in the Fraser. The April flight SWE volume was a bit higher than the April 1st forecast, which gave us more confidence in the April 1st forecasts, and also gave us confidence in decisions based on projections that our system would fill, like not pumping Windy Gap project water this year, and making preemptive releases from Willow Creek Reservoir and timing outages. So we've started working on some analysis, though, like I said, we have a lot more we'd like to do. We've been comparing the ASO data to other snow products that we use to give us some more context for that data, and things like that. We've found that in both years, the ASO volume was about 10 to 20% lower than our other snow products that we use in the April flight, and then more similar to the other snow products in the later flight. So again, this gives us a little more context for using those other data sources, some more information about the basin hydrology, and it's something that we'll continue to look into. I also did some comparison of elevation distribution between April flights last year and this year. We had much more snow at all of the elevations this year, but especially at the lowest elevations. We had 73% more snow at the 9,000 to 10,000 elevation band, and 269% more at the 8,000 to 9,000 foot elevation band. So overall, the ASO data gave us some more confidence in the forecast this year, and it gives us many opportunities for analysis. So we have many things we'd like to pursue in future work. We've started analyzing runoff efficiency. We plan to continue this analysis and look at the differences in runoff efficiencies from year to year and between watersheds. And we're working on other processes to incorporate ASO data into our forecast models and decision-making processes, especially once we have some more years of data. As Erik said, the Colorado Basin River Forecast Center, CBRC, has been kind enough to provide experimental forecasts incorporating the ASO data in 2022 and 2023. And the results from 2023 are shown here. The ASO flights seem to have mostly positive effects on the experimental forecasts in 2023, except for the May flight in the Willow Creek Basin, which had a very slight detrimental impact. But there were other factors at play this year, like a wet spring that impacted the forecast accuracy. And also in 2022, which isn't shown on this slide, we had kind of the opposite experience. The experimental forecasts were generally decreased and less and farther away from the actual observed streamflow volumes. Though at least some of that might have been due to some inaccuracies in the snow-free base data that has since been corrected. So overall, it'll be interesting to see how these forecasts do in different years and also compare the snow 17 snow with the ASO data. We've also been working with Dave Gotchis at NCAR on refining the WRF hydro models in our basins this year, and we're looking forward to using them in 2024. Lastly, ASO can also provide benefits in the form of better understanding our basin's hydrology. For example, the Willow Creek Basin was heavily impacted by the East Troublesome Fire. The snow-free LiDAR we collected in this area to prepare for ASO flights allowed us to see changes in the land cover, and our post-fire recovery teams are working on using this data to inform their activities. So this is from the snow-free data before the fire. You can see the fire outlined in red, the fire area outlined in red here. And then this is after the fire. You can see all of the vegetation that has gone as a result of that fire. The snow measurement flights in this area also allow us to analyze snow distribution and melt patterns in the burned areas to learn more about how fire can change snow processes. Here, this is the snow on flight from April this year and then May of this year. Forecasting has also been difficult in this basin. since the fire, with fire impacts being difficult to quantify and to separate from other impacts like the spring precipitation and uncertainty in the snowpack. So the ASO data helps us to better understand the changing hydrology of the basin, and it helps us to also constrain some uncertainty in a basin where there's significantly more uncertainty than there was previously. So that's all I have for now. We're looking forward to more ASO flights and some deeper analysis. But thanks for your time today, and feel free to reach out. That's my email there. Thank you.
Awesome. Thank you, Emily. Any questions? Eli. Grayson's coming at you with the mic.
Hi, Emily. It's Eli. Thanks for the talk. It's great to see the applications in Colorado. I was just wondering on the CBRFC experimental forecast, was that recalibrated using the ASO data, or is that just using direct insertion? Because I was wondering, when you see those potentially like detrimental forecast effects, if that could be the effect of like a pre-existing bias or cross compensation in the model that's not handling a less biased snow product potentially. Because when I was doing some similar experimental forecasting in California, and we really see the ASO benefit when we use recalibrated models.
Yeah, for sure. That's a good question. And that is just direct insertion. There hasn't been any other recalibration or changes to the models. I think there's a lot of complication involved with recalibration and adjustment. So I think that's kind of an ongoing discussion at CBRFC, whether to calibrate and make adjustments. And I think also looking at how the ASO data compares with that Snow 17 modeled snow can help us to understand some of those differences. But yeah, it's like you said, there's a limit to how beneficial the data can be without other adjustments, at least in some basins. But yeah, we'll see what's possible in future years.
Thanks. Looking forward to seeing where it goes.
Yeah, good question, Eli. I'll note that Cody Moser's here. We'll be talking about the CBRFC efforts in tomorrow's modeling session.
Great.
Other questions? I got a question for you, Emily. You mentioned in your motivation slide the CBT quota allocations. We've got Scott Griebling up next talking about the Front Range ASO efforts as well. How much do you look to Front Range water supplies from those east draining basins to impact the potential demand side of that quota? And how does that feed back into your data needs on the West Slope?
Yeah, the East Slope supplies and demands are also very important in that CBT quota decision. Our board makes that decision, and we present them with all the data and forecasts from our East Slope basins and West Slope basins. And traditionally, the setting the quota has been a bit more focused even on the East Slope water supply, and also based on how the West Slope reservoirs look. But as there's been more uncertainty and concerns about water on the West Slope, they're kind of a bit more equal now, but it's really up to the board. But yeah, both the East Slope and West Slope data are extremely important in setting that quota.
Awesome. All right, I think that's it. Thank you so much, Emily. Appreciate it. Great stuff. Next up, I'd like to welcome Scott Griebling from the St. Vrain and Lefthand Water Conservancy District. He's a water resources engineer and has been really a catalyst in bringing all of the Northern Front Range communities together to get the the ASO program off the ground this year. So Scott, welcome. And
thank you.
Hi.
And Jeff, you stole some of my thunder. I've got a slide on Northern's east slope use of our data.
We'll call it foreshadowing. Sorry about that.
Yeah, exactly. I like that. Well, thank you very much. I also would love to be there in person, and unfortunately had a board meeting and other things this week that kept me here, but maybe next year. So ASO on the North Front Range. Let's see here. There, slides are advancing now. You guys have seen the map of Colorado, but just to zoom in, we're talking about this area to the north and west of Denver. Long's Peak is the tallest peak in the area. This is a snowmelt driven system. All of the basins that we'll be talking about drain into the South Platte River. This is the main watersheds that we're focused on. And a little bit of motivation. This area has the bulk of Colorado's population, or a large chunk of it. And it's also growing really fast. And so water managers have a number of challenges to meet current demands as well as future demands, all at the same time balancing agricultural needs. This is a large agricultural producing area of the state. And then there's tons of recreation, and that is increasing. And then all of that needs to be balanced with ecological needs. There's Rocky Mountain National Park and other key natural areas all on these watersheds. And this area has also been impacted by large fires. Emily mentioned one of them that actually came up and over the Continental Divide and impacted both sides of the divide. And then there's been several other large fires in the last 10 to 20 years. All of this means changing operations, changing snow accumulation patterns. And our current tools are, this is going to be a little bit redundant, but current tools are SNOTEL and a little bit of snow course. This area does have, compared to some other parts of the state and the country, actually decent SNOTEL coverage. But even within that SNOTEL coverage, you can have good coverage, but the information that it tells you about the whole basin snowpack, as you guys all know, is limited. This slide shows May 21st snow accumulation, and you can see the 3 SNOTEL sites show little to no snow, depending on where you are in the basin. So there's still a lot of information that water managers can gain from better snow and better snow data. And that's where ASO comes in. Erik did a great job of going over the history of CASM, and the several entities on the North Front Range were very interested in CASM as it kind of got kicked off. And that led us to the, in 2022, sponsoring or contributing funds towards the larger statewide effort to get snow-free data for our area. And Northern Water in my district chipped in some matching funds that helped leverage the state funds. There was a large amount of state funding to get the snow-free data. And so once we had that data, we were able to leverage that to get some snow-free flights. And so that's really where the coalition took off. So we went from having just a couple entities contributing funds to 11 different entities contributing funding towards getting snow on flights for this area. So really the state's contribution of the snow-free data, their big push to get that was the catalyst for municipalities, water districts, and even some local ditch companies that I don't have shown here, Lefthand Ditch Company and Highland Ditch Company, all contributing funding towards this effort. And originally were going to be 2 flights in 2023. We were hoping for peak SWE and then a later meltout flight. And because of crazy weather conditions, we had like clouds for a month straight. We weren't able to get peak SWE, but we were able to get that later flight. So that was really helpful. Good to see kind of what the data showed, get to, an initial sense of how much volumetrically, how much these watersheds hold. And then for 2024, we're hoping for 1 to 2 flights. We have as Erik mentioned, we've submitted an application with the Buereau of Reclamation, hoping to get some of their snow forecasting funding for flights in our area. And we'll see where we go from there. One of the big questions is this kind of chicken or egg situation where, how do we use this data, and how do we build this coalition, and how do we keep folks who have contributed funds in the past motivated to continue putting money towards ASO flights? Both individual entities, local entities, the state, and there's certainly a large recognition of the value of ASO data. But when it comes to writing checks and when it comes to actually operationalizing that data, there is this chicken or egg situation where you need more flights and more data to really see how the data can be used. And then once you can see how the data can be used, that helps to justify the costs. It's been really cool to see many entities step up and say, yeah, we believe in this and don't quite know how we'll use it, but we want to fund these flights to get a better sense of, to invest in this data set for better decision making down the future. I'll go through a couple examples of how the data is being used and start with Northern. So Emily just talked to you guys about how ASO is being collected and used on the western side, so on the western side of the Continental Divide. And then with Jeff's question, she also talked about how the front range supplies are being used. So a better understanding of front range snowpack directly goes into setting the allocation for CBT water. So that basically, in most of the entities, most of the municipalities and several water districts, ditch companies, irrigation districts, all of that, you have some portion of their water supply coming from CBT. So this helps to determine how much of that will be available in any given year. And Emily's starting, and other folks at Northern are starting to ingest ASO data into those decision-making efforts. I think it's a process of really understanding, are you just replacing SNOTEL data? Are you using it kind of in conjunction with SNOTEL data? And answering those type of questions is very much seems to be the place where Northern is at the moment, and several other entities are at the moment. Another example is the city of Golden. So this is kind of directly to the west of Denver. A smaller city compared to some of the other ones along the Front Range, but has been a strong supporter of ASO, and they are looking at, one of the ways that they're hoping to use ASO data is to inform their drought management plan. Snowpack is one of the factors that goes into a spreadsheet model that determines what their current drought status is, and ASO will help inform and help refine those snowpack numbers. So certainly agriculture looks at snowpack and looks at ASO data. And this is an example of one farmer who is also on the Colorado Water Conservation Board. So Erik works for the CWCB, and Robert Sakata was very gracious enough to talk with me about some of the ways that he would like to see ASO data, or he might use ASO data in his farming applications. And one of the main ones is figuring out which crops to plant. So if it's a water flush year or a water short year, that's going to impact which crops he plants. That's going to impact which seeds he buys. That's going to impact, what type of staffing needs he might have. And the more advanced notice and the more higher quality data he has to help inform those decisions, the better decisions he's going to make. And finally, our Conservancy district operates an augmentation program. So that's a Colorado water loss specific way of using water supplies to help meet a variety of needs. But there's a couple of small reservoirs that we operate. And the way that we operate those is going to be impacted by the amount of snowpack that we have, where we have kind of one higher in the system, one lower in the system. Where we move water between those two and which we plan to fill is going to be driven by the amount of snowpack that we have available. And so our decision making is improved with better snowpack data. Again, we don't have super highly refined models at this point that's where we would plug ASO data into that. It's more just looking at the data and having it be a qualitative, informing our decision making a little bit more in a qualitative sense. The biggest piece I think that ASO data is bringing to all water managers across the Front Range is really helping the shift from looking at snowpack as a percent of normal to understanding it more as the volumetric SWE. So getting a sense of just how many thousands of acre feet are available in any given year. And I'm really excited to see how, with multiple years of data, as we start to gather a better sense of, how much our individual basins can actually hold, how much water they actually hold, and how that water might come out as runoff and can be used throughout, all of the different, to meet all the different water needs in our areas. That's all I have. So thank you.
Thank you, Scott. Yeah, as Scott mentioned, it was a challenging weather year in the Northern Front Range with what we knew was a pretty sizable snowpack up there. So we were trying to delay and capture peak SWE, and then it just socked in. And then once we did fly in May, the smoke was coming down from Alberta, and especially the Poudre River flight, you couldn't barely see the ground. I think Dan had some good pictures of that where you couldn't optically see the ground, but you could see no problem with the laser scanner. So pretty interesting conditions, challenging in the Front Range this year. Thanks for the overview there, Scott. I think one thing that occurs to me that you've done some real yeoman work pulling together all of the different Front Range entities to sponsor and coordinate the project to date. What's your sense on what that looks like going forward? Obviously, all of those entities will continue to be engaged, but is there does that motivate? Does the future of the program depend on that motivation still being there, or do we need a kind of different leadership and kind of statewide effort to support that?
Yeah, I think that's a pretty critical question, Jeff, and I think we are really hoping to see a shift in the funding sources from local entities to more federal and state funding. I think local entities certainly understand the value of that, and I think it's shown in their contributions in the past. And with, if we do get this Bureau of Rec grant, then that will really help. Will help the local entities be able to fund ASO flights at a sustainable level for them. I think there are several entities felt like their contributions to get things off the ground in 2023 and were a down payment in a sense, like an investment. So I meant to say this, but the 2023 snow-on flights were covered. About 65% of that, the funding for that came from the state, and the other 35% came from those 11 different entities. I think those entities would like to see that number closer to probably 10 to 20%, and a larger chunk coming from state and federal, just to make it more sustainable. I also think as the data becomes more commonplace and folks understand how it can be used, you might see even more entities and water users willing to pay in at a lower level to some $5,000-$10,000 annually instead of like $25,000 to $50,000 annually.
Cool. Thank you. Tom's got a question. A comment.
Scott, this is Tom Painter. I just want to thank you for coordinating this and pushing this through. And in particular, it made me really happy because it was coming home for me. I was nearly born up the Poudre Canyon. My mom went into labor up there while my dad was fishing, and she had to chuck rocks at him to get his attention.
That sounds like a great story.
To get going in the car. So at any rate, just seeing this happen in the Front Range now is coming home of ASO, and in particular for me. So thank you.
You're welcome for all my efforts, and it really has been a lot of folks working together on this. So Thank you, and I'll pass that thanks on to others.
Yeah, thank you for the talk. I thought it was super. Oh, my name's Kat, and you can't really see any of us. I thought it was super interesting that you were saying how you want to have that open communication for like agricultural decisions and small farmers or just farmers in general. Where do you see that communication pipeline kind of coming from and going to for that real-time data for them to make those decisions?
Good question. Did I cut you off? Was that sorry?
That was it.
Okay. So Colorado has the basin roundtables. So each major water basin in Colorado has a roundtable, which is a group of members, water managers, members of the public. And that's one of the main areas that we are hoping to disseminate this information. So certainly municipalities, but also irrigation districts, water conservancy districts, and some even individual farmers participate in that. And so that's one way that we can get the data out. By sharing the data with the roundtable, it can get to a large audience in that way. Also hoping for irrigation districts participation. Certainly as a water conservancy district, we partner with many local irrigation companies and local farmers. And so we're working to make the data available with our stakeholders in our district.
Cool, thank you.
I really also want to point out that the CASM work group it's been great to be involved with them, and they have on their website, I believe all of the flight reports are made available on their website as well. So, there's lots of publicly available information, and the trick is just making sure people know where it is and where to get it.
Yeah, great point. Lots of efforts underway across the state to bring all the stakeholders together and ease that information flow. Any other thoughts or questions for Scott? Scott, thank you so much. Really appreciate you to chiming in here.
Thank you.
For our final talk in this morning's session, I'd like to welcome Nathan Elder, who is the manager of raw water supply for Denver Water. And Denver Water's been a great partner of ASO for the past number of years, and we've been expanding the source areas for them that we've been flying. So excited to have you here, Nathan.
Thanks, Jeff. I just want to start with the number 0.035. That's an R-squared value for one of our correlations within our Fraser River collection system. If you think back to your statistics, R-squared value 0.5 to 9, that's good. Below 0.5, okay. 0.035 really tells us nothing. So one of our big motivations for getting ASO in our Fraser system is to learn a lot more about where that snowpack is and how that's translated into stream flow. I'm Nathan Elder, manager of raw water supply for Denver Water, and today I'm going to be talking about Denver Water's Fraser River collection system, how we used to operate and do our forecasts, and how we are using ASO to currently do our operations and forecasts. So start out with a bit of Denver Water background. One of the oldest water utilities west of the Mississippi. We were founded in 1918. We serve 1.5 million people, or 25% of the state's population. We do that using less than 2% of the water generated within the state of Colorado. And our collection system covers over 4,000 square miles. The map here shows our collection system. In yellow, we have the South Platte. In blue, we have our Blue River collection system. Outlined in pink is our Williams Fork collection system. And then here in green is our Moffett collection system, which I'll be talking a bit more about today. So our Moffett collection system, this is 20% of our supply on an annual basis. It covers both sides of the continental divide. So we've got our west slope portion, and then our east slope portion that includes South Boulder Creek, Gross Reservoir, our South Boulder Canal, and Ralston Reservoir. So even though this is 20% of our supply, only 10% of storage is within this system. So we are storage limited there. Taking a closer look, we've got 34 miles of canals, pipes, and tunnels, 30 individual diversion points, 6 sub-watersheds, 2 snowtail sites, and then we've got 1 CBRFC stream flow forecast point shown by the black star, and that is the Fraser at Winter Park. And then here you can see our Moffett Tunnel that takes water from the west slope over to the east slope. Here in blue is our system of canals. So from north, this water flows south to the Moffett Tunnel, and then from west, these diversions take that water east to the Moffett Tunnel. Typically, this system, we only have this one forecast point. So the way we operate is take as much water as we can as soon as possible to ensure we have that supply.
I think you froze. Or
year in and year out.
Can't hear you, and you're frozen on the video.
Oh. Is that any better?
Nathan, are you back? Aha, there you are.
All right, can you hear me?
Gotcha. Sorry about that. Not sure where the tubes broke down there.
Yeah. Jump back in here. All right, so I'm not quite sure where I dropped off.
You just mentioned the RFC forecast point, I believe.
Okay. Yes, we have one forecast point here, and that basically just covers this section of the Fraser River. So typically how we operate this system, we open up all of these diversions in average and dry years and just take as much water as we can, as fast as we can, because we really just don't, other than, again, this Fraser area, we really just don't know how much water is there. On this slide, here are a few examples of the forecast tools that we currently have available to us before ASO. Again, we take the CBRC forecast point and using historic data, develop regression relationships with the amount of flow available at each of these points. And some of these are okay, as shown by Fraser River compared to our Elk Creek, but even this point, Little Vasquez, which is pretty close to that forecast point, that regression relationship really tells me nothing. So year in and year out, the variability of the distribution of the snowpack, we don't know which part of the system is going to produce. So again, for us to operate, we'd really just take all the available water as quickly as we can. And then once we fill Gross Reservoir on the other side, we just start bypassing these diversions, basically choosing which one is easiest for our staff to get to and shut off. We've also tried regressions. There are snow-tail sites in here, and we tried using those regressions, but again, really poor relationships. So when we've been applying the Fraser River ASO data that we received this year, we've been able to selectively decide where to spill. And this is our April 16th ASO flight. And then each of these triangles corresponds to one of the 6 sub-basins within our Moffett system, and gives us a number of at least the amount of water contained in the snowpack there. And that's a lot better than we've had before. Really flying blind before. Now we have a number, and we can start to have conversations about, well, where should we take this water? If we know the amount that we need, how do we operate this system differently? So a few of the things we did this year, we didn't take any of the water in this Meadow Creek system during runoff. And what that did is it allowed us to have flushing flows on Meadow Creek. And then we also shut off some of these diversions, and that leaves more water flowing through. It's kind of hard to see here, but Fraser and all the way to Tabernash. Ranch Creek and these other diversions don't come into the Fraser until right below Tabernash. So it leaves a lot more water flowing through for that local community, for those recreational opportunities, fishing. And I think it's a much better way to operate our system now that we have that information. And then so we just selectively were able to take water from a few of these points in the Ranch Creek Basin, and that was enough for us to meet our needs. So here, a few of the improvements I see using the ASO data gives us more operational certainty of where should we spill, where should we shut off those diversions, knowing that other ones are going to produce. Gives our staff a bit more operational flexibility. Again, not having to turn on 30 diversion structures and just taking the water as quickly as possible. Again, we can bypass some of those, leave some of those off, so selectively take others, and then we can benefit the river and the environment by, again, selectively taking some of those, leaving water in the longest stretches of that Fraser River through the town of Fraser all the way to Tabernash. So just to wrap up, we've been dealing with a complex system in the Fraser River with multiple diversion points, 6 sub-watersheds. We really have deficient regressions that don't give us a lot of information and kind of force us to operate in maybe not the friendliest and best manner for the environment. Again, just taking all the water, opening all those diversions and taking as much as you can, as quick as you can, to ensure that you fill. And ASO has given us an opportunity to improve those operations, have more conversations, with within our own Denver water team, and then within the communities in Grand County of where they would like to see more water bypassed as well. So overall, massive improvement, I think, in the way we operate our Fraser River system because of the data that we have from ASO. And any questions?
Thank you, Nathan. That was awesome. Good to see. Good to see some of the Moffett system coming into the ASO purview here. Really, really cool. There's a question in the back. Seth.
Yeah. Hey, Nathan. This is Seth Shanahan with Southern Nevada Water Authority. Great presentation. I appreciate it. It's very enlightening to see how the data are used by Denver Water. What kind of lead time do you need with that data to make those decisions? Or what's the ideal lead time?
Really around we're targeting peak SWE. So with a full staff, it takes us 24 hours to get to all of those diversions. So we don't really need a huge lead time, but when we're talking about having the conversations with stakeholders and setting up those meetings, having that data available in April to start to know where to bypass those diversions in May, and having a month lead time is useful.
Cool, thank you. Other questions? I've got one for you, Nathan. We've been flying in the Blue River for a number of years, and it feels like you've got a pretty good handle on what the ASO data, how it can be put to work, or at least a couple of ways can be put to work in that system. Now this year we hit a good selection of your full collection system on the west and east slope. How do you see the expanding program kind of serving your full collection system needs beyond just operating kind of one set of diversions?
Going back to our big system map, it's an integrated system. So decisions we make in one area impact the other. So how much water we take in that Fraser and send to Gross Reservoir and a treatment plant then impacts how much water we need at another treatment plant in our south system, and then how much water we take through Roberts Tunnel. So all that is to say is I think it's only going to improve our operations and help us make more informed decisions on, year in and year out, where can we use our supply in the best way possible. And what I mean by that is not only meeting our customer needs, but meeting those recreation needs and shareholder needs, and getting the most out of every drop possible.
Yeah, awesome. Honestly, I felt like I understood your Moffett operations, but I didn't quite realize that you guys just opened everything up and just grabbed everything you could early on. So that seems like a pretty significant shift in the operational mentality there, and I'm sure the locals appreciate that as well. But lots of complications with moving water across the divide.
Definitely.
Any other questions for Nathan, or we can open it up to any questions to any of the presenters from the morning session, and likewise to all of you online. I can't quite see the Q&A box. I don't know if there's any. We got nothing online yet. Okay. All these folks get to talk to each other weekly, so they probably don't have questions for each other. Question from Joe.
So I was just curious about the total volume you would take through the Moffett in the past. I mean, did you ever overtake? Or, I mean, maybe that's not a polite question to ask, but like opening them up and taking it all instantaneously, I can see could lead to some problems, right? And I'm just wondering, are you able to take less, I guess, is what I'm asking, and still meet your needs?
Yeah, we are. There have, been times in the past where, we have taken too much in the spring, and then we completely shut the Moffett tunnel off, and that can cause its own issues. When we do that, it's a pressurized pipe, and it needs 24-hour surveillance by our staff, which becomes an issue. And unfortunately, the timing didn't line up this year, but we also have, to a lesser amount, water rights on the east slope in South Boulder Creek. So if we could get ASO data to line up for the same dates on both of those basins with some of the front range flights, that would be another data point to help us and give us an indicator of how much water we should be bringing over, and if we can, bring it over at a slower rate and distribute that differently.
Nathan, you guys are doing a pretty significant dam raise on Gross Reservoir these days. How do you see the improved knowledge of the whole Moffett and South Boulder Creek system playing into how you manage the changing reservoir storage you'll have in the future?
It's going to play a lot into it. That's why we're excited to have it early. So, we don't just get to fill the dam up with water once it's raised in any way we want. There's a lot of definitions we have to follow around wet, dry, and average years. We have to look at how much water we historically would have taken, and then how much might be available that's called project water to fill that dam raise. So I think, again, and then when we want to make those bypasses for the stakeholders in the community within the Fraser River Valley, having that ASO information is going to help us do all of those things better.
Awesome. Yeah, quite a challenge with all the infrastructure you guys have going on. All right. If there's no other questions, I think we can bring the morning session to a close. Big thanks to all of you for your time and dialing in and dealing with our internet issues here at the end of the pipe in Mammoth, and giving us some insights into the Colorado program. I believe we're up for lunch next.
And so without further ado, I'll hand it over to Steve Hunter, who is the Utilities Resource Manager for the City of Aspen. And he's going to be talking about ASO in the Roaring Fork Valley and the Frying Pan Headwaters. This was our first year of ASO surveys up there in the City of Aspen. Actually, that's not entirely true. We've done surveys in the Castle and Maroon Creek basins before now, but first time doing the bigger Roaring Fork and Frying Pan Headwaters area. And I'll let Steve take it away.
Thanks, Kate. Can you guys see my screen?
Yes, you're great.
Perfect. Okay, thanks everybody. Yeah, your glasses aren't dirty from lunch. That is an extremely dirty snowpack, which we'll talk about here in a second. Like Kate said, my name's Steve Hunter, Utility Resource Manager for the city. I also have some cohorts here that help me with this that are also heavily involved with the ASO program going on the western slope of Colorado. Dave Kanzer, who is the Director of Science and Interstate Matters at the Colorado River District in Glenwood Springs, Colorado. And April Long. And April is the Director of Root Eye Water and Power in Basalt, Colorado. So with that, I'll jump in and give a quick overview on ASO and the Roaring Fork. If you're not familiar with the Roaring Fork, we're in western Colorado. We're at the headwaters of the Upper Colorado River Basin. We, the City of Aspen, and I believe the River District, and even April at the RWAPA, are at the infancy of learning about this and applying this new technology. That said, we're super excited and we can see the benefit in this. We're excited to be working with groups like ASO, CBRSC, NCAR, and CASM and others during this process. Oops, let me get my screen working here. So today I'm going to talk about the three organizations that we are, the River District, Root Eye Water and Power, City of Aspen. Then I'll touch on ASO and the Roaring Fork Watershed. Also Snowtel currently in the Roaring Fork Watershed. And since I'm doing the presentation and I work for the City of Aspen, I'm going to focus a little more about what I know and what we're interested in. Castle and Maroon Creek sub-watersheds, where the City of Aspen gets the majority of our water. And then what we've learned so far. I'll also touch on water supply and drought forecasting, and then we'll end with a couple questions if you have any. So there again, the three groups, we have different missions, but we're all excited about employing new technologies to increase the accuracy of the snowpack measurement and water supply forecasting in the Roaring Fork and surrounding subbasins in western Colorado. And we also have a focus on improving operations and operational forecasting of both Root Eye and Green Mountain reservoirs. Three of our organizations have a vested interest in Root Eye Reservoir, and the River District is focused on Root Eye and Green Mountain Reservoir. So you've seen this slide earlier today with some great presentations this morning from some of our colleagues. All three of our organizations are members of the Colorado Airborne Snow Measurement Program, or CASM. You heard Erik talk about this, so I won't belabor this, but it is 100 plus local, state, and federal agencies across the state of Colorado. Once again, you've seen these different watersheds broken up that have been flown for some years and are going to continue to be flown, including 24 and beyond. We are, if you can see my cursor, we're located right here in west central Colorado. We're a basin that's approximately the size of Rhode Island. We're about 1,450 square miles and produce a lot of water for a relatively small watershed. So this is Green Mountain Reservoir in the upper right here. That's what the River District is focused on, some of their operations. In the center of the graphic, you'll see Root Eye Reservoir outside of the town of Assault, Colorado. And then what I focus on in addition to Root Eye is the upper Roaring Fork, including Maroon Creek and Castle Creek drainages. Aspen, Colorado is right here in the upper basin. And the red dots that you've seen, I think, on some earlier graphics as well, are NRCS Snowtel sites that we use in conjunction, have used historically prior to getting involved with the ASO program. So City of Aspen, Colorado, just touch base about what we are. We're a small utility compared to some of my colleagues that spoke this morning. We provide water to a little over 11,000 permanent residents and businesses. That seasonal population, just like Mammoth, can balloon to over 20,000 additional in ski season and summer tourism seasons. I'll touch a little bit about our main water supplies in the sub-basins of Castle and Maroon Creek. We rely heavily, if not almost entirely, on annual snowpack. That is our largest reservoir up here. We have minimal water storage. We have, and I use the term reservoir loosely here, we have a small 12 acre foot reservoir at the water campus where I sit now above Aspen, Colorado, which is approximately 1 day's peak demand for water use in the city of Aspen. So we're looking at expanding that and looking at other redundant water supplies, but would be in a world of hurt if we lost our water supplies from Castle and Maroon Creek. We also own and operate 2 hydroelectric facilities for local renewable power. So here, zooming in, here's our Maroon and Castle Creek. Aspen's right here to the north. These are relatively small watersheds. Maroon Creek on the left is probably 58 square miles. Castle Creek's approximately 72 square miles. These are snow-dominated watersheds, high elevation. Low elevations are above 8,000. And then in the upper reaches of the basins, well over 14,000 with some famous peak like the Maroon Bells and Castle Peak and Pyramid Peak and the like. We currently have a micro hydro on Maroon Creek. So we're not only looking at water supply forecasting, we're looking at both power generation throughout the year, both Maroon Creek and up at Root Eye Reservoir. We're working with the USGS to get an additional gauge on Castle Creek. So both of these will be gauged. What I'm showing here is some Snowtail sites: Independence, Upper Taylor, Schofield, North Lost Trail. This Castle Creek Snowtail, we're currently working with the Colorado Snowtail program to get this installed. We just finished going through our Forest Service permitting. There's a slight chance we'll get this in before the snow flies this year, most likely in 2024. But that'll be the first gauge snow measurement device up in these two basins. Historically, we've used Independence, Schofield, and sometimes Upper Taylor as surrogates to kind of get an idea of what the snow and the SWE is doing in these watersheds that were so critical to us. But after looking at some Snowtail data, and then ASO confirmed this in our flights this year, if we used Independence this year, they were about 100% of SWE at peak SWE of the 30-year median. So they didn't have the snow that over here, Schofield, I think their peak SWE averages 33 inches, and they were well above 55 inches. So, spatially, it didn't really represent these two watersheds. So it's really great getting this data, and we're excited to have that moving forward. So this is a slide I stole from Jeff Deems. So thanks, Jeff. But this is once again Castle and maroon on the left. And you might have heard me mention, hey, we just started this, and then you're seeing this 2019. And I'll ask the ASO guys and gals to correct me if I'm wrong, but basically in 2019, down here south of these watersheds where my cursor is on the bottom of the topo, is the Gunnison National Forest, the Gunnison Basin. And ASO is doing work down there with, I believe, the USGS, and ended up flying both Castle and Maroon. So we have some data that Jeff provided us from 2019, which was pretty cool. I wish this was 2018 because 2019 and 23 were pretty good snow years for us in Aspen. But what you can see is there were some spatial similarities and spatial differences between these 2 years. So Maroon Creek had less water less SWE, in thousands of acre feet in 2019 than it did in 2023. And conversely, Castle Creek, which is the larger of the two and the primary water supply for the city of Aspen, had more in 2019. Both snowtails outside of the basin were showing greater amounts of actual SWE than what the ASO was showing. So many of you may have experienced this. This was a dust on snow event that really hit, and you're talking to Jeff Derry and the folks down there in Silverton at the Snow and Avalanche Center. This really hammered Aspen. It was a pretty significant event, and we knew that it would change the runoff and timing of the snowpack and change the albedo. But this had a secondary effect, and we've known it from previous dust on snow events, where it really affects our water treatment facility. So the guys where we were cleaning filters twice a week, we were cleaning filters 7 times a week, dealing with this dust. And this dust was high in the snowpack, so we knew it was going to be a persistent problem throughout the year for not only the accelerated snow melt, but for dealing with it from a water treatment standpoint. So these are some ASO products. The top one is from the earlier flights. So our first flight were April 11th and 12th. Our second flight was May 28th. And the take home here is we went April 1st, so some beautiful white powdery snow, to April 3rd, very dirty snow, watershed wide. And the ASO flights confirm this. And the take home here is the albedo significantly changed. And once again, it caused twofold problems for us because we don't have any microfiltration system at our little water plant here. So this is the portion of the Roaring Fork watershed that was flown. Once again, I said we're in our infancy in this, so we're just learning. We don't have the period of record that California or even some of the Front Range community does. But some of the things we did see is the watersheds here, which we rely on. You can see these darker blues, which indicate higher amounts of SWE volume up here. So we were lucky. If we were relying on just that single snowtail in the upper Roaring Fork, which didn't get half the snow that it did to the southwest, we would have been off by a ways. We also like to see with ASO not only the spatial coverage from watershed top to bottom, basin wide. We were really excited to see the different amounts of snow at these elevation bins that are outside your typical NRCS snowtail elevation bands. So quite a bit above and quite a bit below. We also like the fact that similar to NRCS, you get this SWE volume in inches, but you also get a volumetric SWE volume from ASO in thousands of acre feet, which helps us as water managers when we're trying to do kind of runoff efficiencies and looking at those things from snowpack, what losses we're going to expect, and then what we're going to have realized in the rivers and the reservoirs. Some other ASO products that we liked was the difference between peak SWE, or not peak SWE, let me back up, from the SWE volumes, both in inches and volumetrically in thousands of acre feet, between our early April flights and our late May flights. And that was really eye-opening. The next slide shows, basically this is a tabular format of the previous slide, but it's showing the Roaring Fork watershed as a whole, and then broken out into the sub-basins, the early flights and the late flights. And our key water supplies is Castle Creek at the diversion. And in that time span, due to dust, sublimation, evaporation, groundwater contributions, we lost almost half of that snowpack. So it was really eye-opening for us to see that. Other products we get is the Wharf Hydro ASO Assimilated Hydrologic Forecasts. This is Dave Gotchis, who I know is there. Him and his team at NCAR, National Center for Atmospheric Research here in Boulder, Colorado. We're actually in Aspen, down in Boulder, Colorado. And they give us a bunch of great products that we're going to be learning how to use and putting to beneficial use to make better water resource management decisions for our small little basins, but also looking at the bigger basins as a whole. And with that, I will try to take any questions. And this is before the Dust on Snow event, and it is not in the Roaring Fork watershed. Thank you very much.
Thanks, Steve. Good stuff, and fun to see some local terrain in the ASO data sets. Pretty excited about that. Questions or thoughts for Steve?
Yeah, I'm Kat. I'm a flight operator for ASO, and it was super crazy seeing the dust event that came in April when I was out there in the Gunnison, coming across and taking all the pictures and the videos for all the stuff. And I was just like, whoa. And then Tom sent me a bunch of dust articles and research papers that I read on the flight back to California just to kind of get more familiar with that. So super cool seeing that imagery in that.
Yeah, and I think that's what we're excited about too, is being able to use, not only the SWE volumes and the spatial distribution of snow that ASO provides, but this dust on snow event, which we're seeing pretty frequently here in the Roaring Fork Valley, and how it affects not only our snow melt, but our water treatment processes. So it was a pretty significant dust event for those of us that were here for sure.
Yeah, and it did crazy things to the snowpack immediately. Steve and I were out in the field digging a snow pit. I guess it was the day after we flew.
Yeah.
And the snow had been cold and it got just cooked by the dust, and it was rotten as hell. We were post-holing on skis. It was pretty nasty. But I think we at least impressed the reporter that was with us. Steve, you guys are putting in a snowtail up there. We've seen in other watersheds that the combination of the two technologies, the time continuous observations from the stations, combined with the spatial information from the ASO flight surveys, really helps keep the models on track. Excited to see how that goes in Castle Creek. How have you guys, you started citing that snowtail before we had the ASO flights in there. Did you see anything in the data this year that led you to second guess where you're putting that snowtail station?
No, not really. And all of us have seen it. We all looked at it, and Carl and Brian at NRCS Snowtail in Colorado didn't have any red flags with that. I think that we've been trying to get a permit for that location from the Forest Service for 3 years. We also didn't want to move it, but no, we didn't see any major red flags that would make us want to change it. But that's also just 1 year or just two sets of flights.
Yeah, for sure. usually in the case where the stations have been there a while and we're flying in and it just is what it is. And here it's not there yet. And, you know, yeah, you don't want to go through the permitting again, but kind of an interesting concept to think about where you would want it, or another one even.
Yeah, and Gus Goodybuddy from the NRCS there out in Portland was big at looking at all the watersheds, looking at what they had, and trying to fit out, you know, find where, because if the city just wanted a snowtail, well, that it didn't fit with the NRCS snowtail program, that doesn't work. So Gus did find that there was a distinct hole in that location because Independence, North Lost, and Schofield don't necessarily represent those two sub watersheds at all.
Yeah, Gus will be here tomorrow, so we'll get him on record on that.
Perfect. He's the man to ask.
Hey, Steve, I think you said there was a disparity between, was it Independence Pass and Schofield, which are both outside the basin. In the absence of the ASO data, how would you have gone about reconciling those differences for making decisions in the basin?
Well, a bunch of us are skiers, and we have a bunch of backcountry skiers. So, and we also, I communicate with Jeff Derry at the Colorado Snow and Avalanche Center down in Silverton. They have a space near the McClure Pass site, so we can also keep talking to different folks that are bouncing around the watershed, either scientifically, backcountry skiing, doing other sorts of things, or even some folks that are flying. We have pilots. So we just kind of piecemealed it. We never had this kind of technology before. You also get a pretty good feel when you go up Independence. Wow, this just isn't a good, you can get a feel, having lived here for the majority of my life and being an old ski patrolman, old ski bum, you do get a feel for how much snow is out there, though it's not quantifiable per se.
Here you go, Evan.
Steve, name's Evan. I'm just so the increase in turbidity from the dust is interesting to me. I'm curious, did the dust have to come to the snow surface for the turbidity to really kick off, or were you seeing increased turbidity when the dust layers were still buried?
Yeah, great question. Actually, it wasn't the turbidity. So we're used to dealing with the turbidity from these kind of Roskin type A stream systems that flush out some flows, and we can deal with it. And the turbidity, the suspended sediment seem to be larger than these dust events, these really fine clay particles. And I'm not a chemist, I'm just a hydrologist and water engineer, but the guys at the treatment plant are finding that these things clog our filters. And they can treat them pretty well if they're a positive or negatively charged particle. But if they're neutral, and we're doing a bunch of tests on this to see if we can kind of target how to treat it better, it's real difficult to treat and real difficult. So the only option we have now, and we're working some treatment professionals from the Front Range on dealing with this, is how we can not go to clean filters twice a day to keep up with it. And to ask about it, it kind of, and Jeff has seen this on our basin. It was basin wide and it was on the top of the snowpack. So obviously if you got a dust on snow event that's lower in the snowpack, that's better for you because it doesn't be a persistent nuisance, which this was throughout the snowmelt season. So we were realizing not only the turbidity spike was not terrible, but the dust was because it just kept melting. So it's realized at the water treatment plant at our intakes. So we were just getting it consistently because the dust was throughout, as it chased higher and higher in elevation, we were still picking up the dust at the water treatment plant.
Crazy. All right. Other questions? Tom wants a dory ride. So
yeah,
probably not the only one here. Steve, thank you. As long as it's a year
like this year,
Totally. Steve, thank you so much. That was great. Really excited to see the progress in the Aspen's watersheds, and looking forward to keeping that going.
See you back in the hood.
Yeah. All right. Next up, we've got Susan Behery from the Bureau of Reclamation down in Southwest Colorado, where she's a hydraulic engineer and really does a lot of the reservoir operations and forecasting down in that neck of the woods. Susan, welcome.
Hi, thank you. Can you hear me?
Yeah.
Great. I'm gonna share my screen. I kind of just have a lot of pretty pictures. So, let's see. Are you seeing a presentation?
Got it.
All right, great, thanks. So, I'm Susan Behery. I'm a hydraulic engineer. I work at the Reclamation office, Western Colorado area office. We have 2 offices, one in Grand Junction, one in Durango, and I'm in the Durango office. So I cover all of Reclamation's forecasting and operations in the San Juan River Basin. That includes 6 reservoirs, including Navajo, which is one of the CRSP original projects, and as well as McPhee Reservoir in the Dolores Basin, which is the one we're going to talk about today. So Reclamation, we coordinate operations with the district, Dolores Water Conservancy District, for their day-to-day operations. And then during spring runoff with big snowpack, especially with big snowpack years like this, Reclamation helps oversee those operations. So I already switched. So this is the state of Colorado. The Dolores Basin is the little guy down here on the bottom left. If you look at our actual basin itself above McPhee Reservoir, this is McPhee down here. It has a diversion that takes a transbasin diversion out. And most of this reservoir is for irrigation. And then we're in a water short system. We're, on the edge of the desert. So obviously water and the exact accounting of water becomes a pretty big deal down here. So most of the water in McPhee is for irrigation and also for the Ute Mountain Ute tribal settlement. So we have, a lot of mixed use in this basin. We do have I don't know. I mean, I feel like it's a fairly good snowtell site for the Southwest. I don't know if it's good, when you look at other places like the Front Range or California, but, we do have 1, 2, 3, 4, 5, 6 snowtell sites right in the Dolores Basin, which is pretty good relatively. I have several other basins that have maybe 1 if they're lucky. So I do feel pretty good about that. And then also the San Miguel system, which is just to the north, has at least 1 snowtell station that we look at. One thing that is real common down here in the San Juan basins is extremes. So, and with climate change and aridification, I think we're going to expect more extremes. And what hates extremes is agriculture and production. They like to know that they're having an average or something, consistent supply every year for agriculture and ranching. So the last few years, especially that we've had down here, 2020 through 22 were well below average, drained the reservoir almost entirely. Last year, the Ute Mountain Utes got something like 10% of their allocation. And this year, we were 200% of average in this basin. So a lot of variability means that you do really need, and this orange line is average, means that you really do need to start stepping it up as far as getting a better handle on your complete volumes. Inflow volumes. These are some pretty pictures. I wish I had taken them, but I was chained to my desk during this time of year. So we have some pretty good, snowpack pictures from the basin, from the Dolores Basin, and we do have some folks that go out and do ground truthing for a lot of our snowtell sites. This is a nice cinnamon roll picture from the dust event Steve was mentioning earlier. That definitely affected us as well, and we had a nice dust layer that we contended with this year. But overall, an unbelievably huge snowpack here. I'm sure everybody's saying that this past year is just an unbelievable year, and I just echo that same sentiment. It was a crazy, above average year. So one thing we've learned though with ASO this year, and I'll get into it a little more, is the complete a different set of applicability that ASO has in a wet year versus a dry year, at least in our basin. We do things completely differently in a wet year versus a dry year. So kind of getting those extremes from last year to this year was pretty helpful. So my ASO presentation here is going to kind of be from an operational side, meaning I don't take ASO information that we get from the flights themselves and ingest them somehow directly into our operations. There's sort of a missing link there. I don't have any ability to ingest direct ASO data. So, I'm mostly using the ASO data as it passes through me from WRF Hydro, ASO informed WRF Hydro, or the experimental CBRFC forecasts. Just want to make sure I didn't miss something. I have a list. But so, we are looking at the ASO complete volumes, the inflow forecast, but in a qualitative sense, we do also look at the albedo, the soil moisture, those extra components, but it is still at this point, still more of a qualitative context situation, get the context for the snowpack in the basin. So what I'm showing here are just some SNOTEL sites in the basin, just to give you an idea of how our snowpack developed, because it really did have an impact with operations. But these are all just in our basin. You can see, we had a maximum peak or close to the maximum peak of snowpack accumulation this year. And the peak snowpack occurred at or a little bit later than average. And you can also see, thing to note is that in most of the snowpack, either that was significant, either fell in January, this kind of first steep line in January, or in mid-March. At the beginning of the season, kind of coming up through Christmas, we were kind of just not sure if we would even fill the reservoir. Following this big January event, we started thinking, oh my gosh, we might fill the reservoir and we might have some water for fish flows for boater spill, which, would be a really big deal down in the Dolores. I don't know if any of you guys are boaters, but if you didn't get a chance to boat the Dolores this year, it was a pretty banner year. You should definitely put it on your list for the next time we have a spill. But most of our snowpack either fell in January and then in March, and those two points in time were pretty significant decision points. I always think, wouldn't it be wonderful if all of our snowpack fell in like December or January, and then we didn't have any after that, or at least it was average, because then, when we have these extreme snowpack and snowfall events, you have to make decisions really quickly. So in the beginning of the season, we were using the ASO, we were planning to use the ASO data in a manner to shape the volume of the fish spill and determine whether or not we would fill and how much water would be available for irrigation. But as we trended from a dry hydrology year to an average hydrology year to a wet hydrology year, the role of the ASO data kind of changed completely. And our focus really came down to timing of the release. And I'll explain a little more of that in a second. So another thing that was kind of extreme this year was the San Miguel, which is the tributary just to the north downstream of McPhee and the Dolores project. The San Miguel basin just had a even higher snowpack. I mean, this is their max, and they were quite a bit higher than their maximum recorded snowpack. So that was added a little bit of complication, challenge. Some people call it fun, some people call it terrifying, as far as releases go. And so this is just one of the years where mid-elevation snow really affected, and we didn't have ASO data for the San Miguel, but the Dolores being so close gave us at least some semblance of information as far as, do we think that the information that's provided in that basin is accurate or skewed? We started the year, this is pool elevation at the reservoir, and these are statistical, historical statistics, basically. So we started the year almost completely empty in the reservoir. And within a less than 30-day period from the middle of April to the beginning of May, the reservoir almost completely filled and gained 47 feet, which is extremely, that's a very steep curve for us. We don't usually gain water quite that fast. And as this occurred, as we watched the reservoir fill at this rate, it became apparent we were going to need to release and make a lot more room and shape our boater spill earlier. So the reservoir ended up releasing up to about 4,000 CFS, which started causing moderate flooding down at Cisco and in Utah and in Gateway. So, you know, the release at 4,000 CFS, the things that really caused were not, for the most part, nuisance flooding. There was other flooding that occurred, but you know, a lot of this happened just because of the extreme high snowpack that occurred. Much of it occurred in March. So we, you know, it was occurring right before we, you know, we could have started moving that water earlier, but it was shaped into a boater spill. There was some moderate flooding. This is kind of how it fell out flow wise in the Dolores, but all of this early snowpack that came off, you know, wasn't something that we were, it was reflected in the ASO data in the April flight, but it was the timing in a high flow season that really made the difference. And this is the Gateway Bridge in May of 2023, and you can see it was just people that floated down at that level had to like duck down and crawl, you know, like be underneath the bridge. And if you had not been paying attention and you've been sitting up, it would have just knocked your head right off. So it was becoming a danger. Also, the water was getting pretty close to the underside of that bridge, in which case they would have to close it. So these were kind of the real-time issues that we were contending with. We had two flights for ASO. We had one on April 6th and we had one May 25th. And the forecast, this is kind of what I do every year with our ASO data. I compare the ASO forecast, the WRF Hydro ASO informed forecasts, with what we normally use, which is the Colorado Basin River Forecast Center forecasts. We also use the NRCS for context, or, you know, just to make sure that there isn't some great disparity. And, you know, what I'm kind of just trying to do is see which forecast was the best and how early. So honestly, almost every forecast did really well this year. Like the 50th percentile in April for the Dolores River, you know, everything kind of fell within the range that we were expecting, between the 50th and the 30th percentiles for all three of them. So I don't think, I mean, I think everything lined up really well this year. And so what we used a lot of the ASO for at this point was just confirmation that there wasn't a ton of snow up there, that, you know, the forecasts we were getting from the ASO informed forecasts were not just drastically bigger than the experimental ones. And they were all, you know, pretty well in line. This is the CBRFC's ESP, their experimental forecast. So this first blue line is the ESP. The second blue line is the experimental. And then this gray one is the CBRFC's May official, and the blue one is the CBRFC's June official. And then the green one is the WRF Hydro ASO informed forecast. And I just put them all together on here, everything that was kind of around that second flight, because that's when it really starts to matter in the Dolores after spilling. And I mean, they were all just very close. So it was very comforting to see that. And I sort of learned that in a really big water year, we are really not as concerned with the total volume than we are with the next 10-day timing. So it's still useful because you need to know how much is left once the snow tails melt out, and you want to make sure that the forecasts that you're using are in line with the on the ground, you know, with the ASO data, with any other data that is using real measurements. And they were just very, very close. So it was really comforting to see that we were falling kind of within the range that we needed. But at this point, when we're spilling, not spilling, weren't spilling. When we were releasing these really high flows from McPhee, I to be honest, I wasn't real concerned with the total volume at that point. I looked at a lot of these as like after we were done with that portion of it, because you just don't care as much. You know you're going to fill, right? So we don't need the exact number until we finished with the boater spill. I think that was all I was going to say about that. So, yeah. So this is really my last slide. It was a really great year to have an ASO flight, just because everything was so dramatically different than in recent years. In recent years, we are looking on the low side of the extreme. We're in drought. Our reservoir needs to fill. So I think we focused this year a little less on getting the accurate volume picture and more on just day-to-day timing. One thing that already came up is the dust impacts. So those do impact our timing, and we're working, we work with Jeff at the Center for Snow and Avalanche Studies. We created, kind of in collaboration with him for our operations, a dashboard to sort of keep following where the dust layers are, when we're going to hit them, and what that would do to the flows in the basin. So I do have some bug in my ear or thought about somehow incorporating some of the albedo data that we're getting over the whole basin into this, because we are getting it daily at this one location at CSAS, but I do kind of, obviously dust coverage is not uniform. So including that and the soil moisture data that qualitatively and kind of informs me or gives me some context for how I think that the snowpack will run off. Yeah, and I'll just add that, while I wish these were me, these are all photos courtesy of Robert Stump, who is the project manager for Reclamation over at the Dolores project. He has kind of taken it on himself, the self-imposed duty of ground truthing every snowpack measurement he receives. I'm really more of a boater than a skier, so I like to ground truth the flows in the summer. We make kind of a good team that way. But I'll stop there, and let me know if you have any questions.
Awesome, thank you, Susan. I share both of your enthusiasms for ground truthing, both the snow and the flow. So you're in good company. Questions or thoughts, Dave?
Hey, Susan, this is Dave Gotchis. Thanks for the next presentation. You mentioned, different forecast needs, I guess is probably the best way to say it. You got a good seasonal forecast from a few folks. You felt comfortable with that. You had other forecast problems you were managing. I think you mentioned a 10-day flow volume. Just for the sake of some future discussions we're going to have here about modeling and what modelers should be providing people, what other forecast metrics out of these kinds of systems would be really helpful for how you guys are managing things? Clearly in the bridge case, it looked like peak flow might be one of those, but what else?
Yeah, peak flow and peak timing, but obviously those depend on weather at the time, right? So, that can be hard to get at, but peak flow, peak timing, the range. And yeah, we kind of, when we're in a situation where we are moving water and we're trying to get water, make space for inflows, the 10-day forecast 15, if anybody has those, sometimes can be useful just to give us a range. Having them probabilistically rather than deterministic would be probably one of the bigger requests. And with Dolores and honestly a lot of the reservoirs in the last 2 decades, I'm sure all of you are familiar with the phenomenon of early runoff, right? So, is this year going to be an early runoff year? What is the seasonality or the timing as dictated by the season would go? So maybe just like a month out kind of forecast. I'm looking for everything, and I want it to all be exactly right. Is that helpful?
Dave's on it. Jed.
All right, question from one operational person to another. For starters, what's the time between when an ASO flight occurs and you get the River Forecast Center integrated data or the Wharf Hydro integrated data?
Yeah, that's a good question. So I'll let Cody from the CBRFC speak more to the specifics of the experimental, but as far as I know, or the only one that I looked at was one experimental after the May 25th flight for this year from CBRFC. And the WRF hydro was coming out about every, I want to say 2 weeks, 1 week. Oh, 1 week. It was 1 week. Based on the most recent, ASO flight. And I did notice that, from the actual date of the model run to the report date, it would be, I don't know, anywhere from 2 to 5 days. Okay. So it depends on the operation. Sometimes that's fine. And sometimes, I'm not even going to use it that much if it's already 5 days old.
So as you described, one of the key issues was your early release, your 4,000 CFS and fitting under bridges and safety and so forth. So your forecasts were fairly well aligned. So it sounds like you were using the ASO informed forecast primarily for confidence, which allows you to sort of move forward, move water more boldly, so that you can ameliorate those high peaks. So that said, if you had a chance to change your 2 flight dates, when would you have selected those flights?
Well, typically we would like to have one at the peak and one right when the snow tails melt out. And that snow tail melting out May 25th date worked out pretty great. Getting it at the peak, which is what I wanted this year, we ended up being a little early. So we didn't get the entirety of the peak. But at the same time, if we had waited for the flight until we had the entirety of the peak, it might have been too late to start releasing. So I think it just worked out this year because between the flight and the peak, it was a few weeks, but there wasn't a super significant amount of accumulation, but that could have easily gone the other way. So I think it was the right flight date this year, but I think it was luck.
So 4 flights is what you're saying we need.
I would like a flight every week if you can swing that.
This is Tom Painter. Thanks for the talk and for going through this. When Chris Graham and I spoke to EB Mudd years ago, they told us they wanted a flight every day, and so we were open to that. This is more so it's following on what Dave was saying and a comment that this year it seems that that across the Western U.S. and across the models, everything did pretty well. I could be wrong, and no offense to the modelers, but I don't think that you guys all of a sudden got everything perfectly figured out. So we may just be in one of those years where the forecast did pretty well, and this is a time for confirmation. And there will be other years of a different distribution and different energy forcings, and that will cause you to use the ASO data in a more direct fashion. So, at any rate, mainly as this is a thing to discuss in our modeling meetings coming up, what was it about this year that allowed all the models across the Western U.S. to do so damn well?
I have a thought.
Do it.
So I'm only speaking for my specific basin, but this spring, we had some wet weather in the spring. We had some in the snow, our March and April period. But if you notice, the flights start in April, right? So they're starting, or at least for us, so they're starting right when we kind of have reached the end-ish of our season. And in some previous years that we've had ASO flights, we've had extreme weather in the spring. We've had crazy May storms that accumulate a lot of snowpack, or extreme dry weather where we have absolutely no rain at all. So I think all of the models did well. At least this is from talking to the CBRFC folks in the past. That uncertainty from that weather window, from the point that you're, in the spring forward, was not extreme. Whereas in the past, when we've had ASO flights, when we've had, especially in drought years, it's just spring becomes very extreme for us. I can't speak for the rest of the basin, but and then also we didn't have some other uncertainty windows, like down here we didn't have extreme dry soil moisture. We had fairly good monsoons last year, so our soil moisture wasn't perfect, but it was much improved. And we also didn't have, we had one dust storm that was, you know, pretty significant, but we didn't have all those dust storms we had last year. Last year's dust storm events were very significant and affected the timing and the runoff. So I think we just had fewer extreme events beyond the extreme snowpack. We had extreme snowpack, but all of those other uncertainty windows were much narrower. That's my hypothesis. I back it up with like no study or real information except my thoughts.
So I was going to provide a couple cents on that as well. From a physical modeling perspective, it's Ronnie here from NCAR. Thanks for the nice presentation. So from a physical modeling perspective, my hypothesis is that on a year like this, it's easier to have an accurate simulation because ET is one of the most complicated things to model. But when the soils are saturated, ET almost equals PET. So it takes out a lot of the water limited nature of the complexity out of that equation. And then whenever there's extra liquid water on the soil and the soil is full of water, it just runs off. And that's a lot easier to model from a physical perspective as well. So it takes out a lot of the complexity of the uncertainties in the model, both from the ET and the runoff perspective, when things are very wet. When things are in this intermediate phase between extremely dry and extremely wet, this transition between water and energy limited, the models may have a lot of uncertainty in ET, which then through a water budget just propagates to uncertainty and runoff as well. So that's a couple of cents and a hypothesis from my end.
That seems coherent. Thanks, Ronnie. You guys, I think, are focusing on a similar kind of compartmentalization of where the uncertainty lies and how big it was this year. One other thing, Susan, that we noticed, well, many places in Colorado this year, but definitely in the Dolores, was low elevation snowpack. In fact, there were boatable flows due to snowmelt below the reservoir pretty early on. It was kind of a bonus boating season there. But then also some low elevation melt causing flooding problems in the town of Dolores. What's your kind of qualitative sense on the role of and unusualness of the low elevation snowpack this year? And are there any operational ramifications for you in the reservoir with that?
Well, I think that we had, more low elevation snow than we have had in a really long time that I think came off rather quickly and early. And I think that we had some lessons learned from the operation this year. I mean, it went fine, except for some of the flooding downstream of the dam couldn't really be avoided just because the San Miguel was sort of running quite high as well. But, we had a lot of lessons learned about operating, just remembering that we can have extremes. We sort of forget because we are always water short in this system, almost always, and we're always in a mindset of trying to save every single drop. So kind of coordinating with our partners and stakeholders and making sure everybody understands, that we're all on board with the numbers that we're seeing and that there really is that much snow up there, and we are going to make a lot of room this year, and we're going to make it early. And I think just kind of keeping all of that communication going and keeping all of that data explained to all of the stakeholders to make sure that they are trusting it as well, because that can sometimes I'm not going to say hinder operations, but just sort of, it's sort of a challenge that you deal with when you have a lot of stakeholders in a project.
Right, awesome. Well, we do have one more question. Yep.
Hey, Susan, it's Cody from CBRC. I guess a comment earlier, I would say about 2 hours it would take us to turn around once the ASO data is on the web to produce that experimental forecast. And then my other question is that dust dashboard that you developed with Jeff Derry, is that publicly available?
I mean, if somebody wants it, I can provide it to you. It's not a secret dashboard. I think Ashley has it actually, but it is hard to run. It kind of connects to our direct database. I can talk to you about it if you want. Certainly anybody could have it. I just don't know if it would run on your computer.
Okay, thanks.
Awesome. Susan, thank you so much. And thanks for all the work you're doing down there. And you're a great resource for pulling together all these different forecasts and techniques and serving as a community resource as well. So thank you so much.
Yeah, thank you. Thanks for everything.
All right. Now, next up, we've got happy to welcome Nathan Coombs, who's the manager of the Conejos River Water Conservancy District and also the Rio Grande River representative on the CWCBE board in Colorado. Nathan, so good to have you here.
Thanks. Can everybody see and hear me there?
Looking and sounding great.
Okay. So I'm not a scientist or an engineer, so I kind of feel like a dirt clod that snuck into the gem show. So hope everybody will excuse my lack of polish here. I am the manager of the Conejos Water Conservancy District, and also my brother and I, we manage a 5th generation family farm. And so some of the data I have, I won't be able to precisely explain, but you got Dave Gochis there who helped us develop all of it. So we'll refer to him. I wanted to start off and tell you why we got where we are. The Conejos River is the largest tributary to the Rio Grande within Colorado. That being said, we're about 1/3 of the size on average, but we have an obligation of almost 40% of the Rio Grande's compact obligation to New Mexico. What happens if you look at this map in 1867 is when main stem Rio Grande priorities were being developed, but on the Conejos it happened clear back in 1855. Generally, an entire river system would have one priority system where everybody is managed in the prior appropriations as one. But because settlements were so far different, we got our own priority system within this tributary to the Rio Grande, which then gave us that compact. Our problem with that is where we owe that 40% on this much smaller watershed is our margin of error is significantly smaller. It's very difficult to pay our Conejos portion. If you look at this, these are the curves of our requirements. I won't go into the geology that brought that about, but for us, a mistake in paying the compact is very hard to make up. And so the obligation we owe is calculated. Most of the calculation comes from how much snowpack we think we're going to have. And so in the past, we used, just like everyone else, we used NRCS forecasts. We had the West Gulf Coast Regional Forecasting Center gave us our forecast. And we always called it hindcasting. I don't know what everybody else calls it, with the kind of the regressive look at what was happening. And so I'll go past that one. What we were looking at is we have within our area here, no snow tells, very few snow courses. So we had a lack of data for a very huge land mass, and the majority of this area is in wilderness. And so we noticed that as time went on, in the past, when they would look at these forecasts and compare this to the past 20 years and pick the best indicators from past runouts to give us a forecast for the future, it was great until things started changing. And just like everywhere in the Southwest, we're experiencing a very difficult situation with aridification. We've had the spruce beetle kill has really wiped out our canopy. And on top of that, you got fires. None of our scenarios in the past that we could use for forecasting had any of those conditions. And so we are seeing this migration of effective forecasts going into the double digits of error. And so when you start getting in that point, our river is so small that if we make a mistake early on, we don't have enough water to correct it. And so we get to a point, and we're in a situation like that right now, where we have our number one water rights, which, like you saw, are established in 1855. They're only able to take 30% of their decreed water simply because all the rest has to go to New Mexico to pay that compact obligation. Conversely, you get into a situation where our mean elevation is about 7,800 feet above sea level where we're farming. And so if we overpay the compact, then our only option to recover that is to extend our irrigation season. But at this elevation, nothing grows in October, past the end of October and November. So we're making an effective use of our water was very difficult. I say that because that's the genesis of why we started in the valley, of looking and working with Dave Goches and Joe Busto and Erik Skeie to try to develop a better forecasting method. One of the things we did is if you look at when we start doing a comparison, we were seeing, you look right here, 07, what our actual was, we missed it by a long ways. And then the next year we go super conservative and you see that we underestimated again. And so we were seeing this whole yo-yo effect. We started trying to clarify it, but our margin of error was just killing us for our irrigators. We had no way of recovering that water. Our reservoir here got some very tight restrictions because of the compact. And so the feast or famine was really turning into more and more and more famine. And so we had to do a whole lot of corrections. But our problem was, how do you collect any better data? Because like I showed on the map, with all the wilderness areas and the very few snowtail and snow course sites, we had to try something different. We initially started working with Joe Busto and doing some experimental radar to start developing some modeling and some ground truthing of our winter snowstorms. And then as that developed, we realized that we could get into what ASO had to offer, and that we could start getting, with the ground truthing we still had in our Forest Service, we could also add ASO. Now, I purposely picked this old slide, and Dave will probably recognize it. I'm sure I stole it from him. 2015 is when we started doing this, and the whole thing was to get more funding and keep going. But we have noticed that I scratched out the will, because it absolutely does do everything we're looking for. We're getting all of our forecasts better. We're getting our forecasts back down into under 5%, into the low single digit margin of error, which for us is huge. And like it says, we're validating that with a radar-based snow accumulation data. We ended up purchasing and building a permanent radar in Alamosa that does see a majority of our watershed to help us see what we're doing here. When we look at what we learned from it, is just like everybody else, and there again, I'm using the old data so that it's consistent, is in the beginning, 98% of our snow was above the 10,000 foot elevation. You know, our whole watershed was covered, but as you see, it's all wilderness. And so then we noticed that even with our snowtail sites, by June, all of our snowtail sites are melted out. The radar wasn't established quite yet. We were still using experimental, but as you see that the majority of our snow is sitting above the 11,000 foot mark. And this is where our biggest margin of error was coming from, our late meltout and our high elevation, because we had no way of knowing what was still up there and what was coming out. We noticed we had a bias in our forecasting to the low elevation sites. And so the ASO flights, and then interpreting that through, of course, the same as everybody else with the WRF Hydro, showed us that we were missing a whole lot of our high elevation calculations. And so as you look at it, that's what we were seeing, is the high elevation is where our biggest inconsistencies were, but that's what the ASO allowed us to start correcting. We were able to start measuring that depth, and we were able to pick up that. I mean, so the way we adjust our compact for New Mexico is we look every 10 days of how are we doing? Are we hitting our target? And is our forecast still accurate? Our traditional methods of forecasting ended in June. And so then we had no forecasts from NRCS after June. And so it was just spitballing it and gut checking it all the way through. And so I don't know if any of you guys work with farmers. I know Susan said she did, but one thing I've noticed about us is there's a joke out there, and it says, what's the difference between a water user and a puppy? Well, eventually a puppy will mature and stop whining, but those of us that are water users, we don't do that. So anyway, we finally started realizing where our mistakes were, where we could start correcting it. And like I said, now where we sit, we're back into those single digit sub 5 percentage point margin of error. You look at this in the beginning, we have to make a compact forecasting curtailment right here. And when you look, I mean, as everybody knows, the closer we get to the end, the tighter we get. But when you look at the variance of the different forecasts and the different projections, that's a lot of head gates that do or don't turn on. And so you want to hear a lot of griping people get in the middle of their irrigation water at the wrong time. So the ASO and the Wharf Hydro has really helped us develop this tighter bunching all the way through. We're seeing that our annual index supplies are better. We're getting a better grouping. And so for us, it has paid off huge. We are committed to sticking with the flights. And like Susan, I don't have a way of ingesting that information. We're not that big of an operation. And so we get the Wharf Hydro forecasts and the data that NCAR gives us. We use that with the National Weather Service and the NRCS, and then our Division of Water Resources works with us to help forecast what's the snowpack going to look like, how do we start adjusting head gates, and then how do we make sure that New Mexico is paid. So that's all I had for slides or presentation. So if anybody has any questions, I'd be happy to answer them.
Awesome. Thanks, Nathan. Questions or comments? There was, I can't remember what, I think it was 2021, maybe we flew for you guys. When we got the data into the Wharf Hydro, it decreased the total amount of water in the basin, but increased the amount above the reservoir. You were mentioning how small the reservoir and how tightly controlled it is for what you can use it for. How does that ability to really capture what's going on in the full basin and above the reservoir impact your ability to serve your constituents as well as meet those interstate obligations?
That's a good question, and I remember that year. What happens is, since our reservoir was built after the compact was signed, certain conditions in New Mexico have to be met before we can do long-term storage in our reservoir. And so we're basically a pass-through. And what happens is, if we have a really good forecast of how the reservoir is going to be able to fill, or if we're going to be able to do some short-term storage to retime some of that irrigation water, it helps us work with the Division of Water Resources of turning head gates on and off. Another thing about it too is when we start seeing those errors at those high elevations and we have the reservoir to buffer it, if we know we're not illegally storing because of the compact, the state works with us very well, and we can hold back some of that water as compact water and release it later in the season when we can get it through our entire system, and then allow the irrigators to have what the river is providing. As you alluded to, one of the problems with our reservoir is it sits at 10,000 feet. So a very small amount of our watershed is above the reservoir. So our ability to manage this water in a meaningful way is very difficult because of the location of our reservoir versus all the watershed that's below it. So better forecasting is always the best answer for us there.
You can actually use the snowpack as the reservoir that it is.
We have to have that. That's exactly right. We have to make sure we're measuring that right.
Other thoughts, questions? All right. Nathan, thank you so much. Good stuff, and can't wait to get down and see you one of these days soon.
Thank you, guys.
All right, for our final presentation in our second Colorado session here today, we've got Sonja Chavez and Bev Richards from the Upper Gunnison River Water Conservancy District, kind of rounding out our tour of the state from this year. So I see Bev, take it away, you guys.
Can you hear us okay?
Yes.
Let's see if Sonja's on yet. Sorry about that. I was trying to get to my mute button in my video. Okay. Can you hear me?
We got you.
Okay, great. Get my thing going here 1 second, please. Sorry, my computer, of course. Sorry about this, folks. Give me just 1 second here. I apologize.
No worries. Take your time. The remote connection is always
I
challenging.
know, and then I've got multiple screens and it's not behaving. Okay. All right, I think we're ready to go. As Jeff said, I am Sonja Chavez. I'm the general manager of the Upper Gunnison River Water Conservancy District. And we also have Beverly Richards online, who is our Upper Gunnison Water Resource Specialist. And we're going to talk to you today about a case for continued use of ASO data in the Upper Gunnison River Basin. We're going to start our presentation by basically setting the stage and making sure that everybody knows where the Upper Gunnison is located within Colorado, as well as the Colorado River system. And I think it's important to also identify federal infrastructure within our basin, as well as important operational agreements and water rights that influence the way we manage our water. We're going to then jump into ASO and talk about it as being that sort of big gun and that biggest tool in our toolbox, but also how we use other water tools within the basin to help us with our annual forecasting and water management. And then maybe highlight some comparisons for the use of ASO data and other tools within the toolbox and the benefits of that. And finally, just really trying to hone in a little bit more on the benefits to our local community for you all. So this first slide is a slide of the Upper Gunnison River Basin located in the upper basin of the Colorado River system. It's that red circle there that you see in the map on your left. And on the right, that's just an inset of the Gunnison River Basin as a whole. And that red line that you see there in the middle of the map is really that just a very general dividing line between what we call the Upper Gunnison Basin and then the Lower Gunnison Basin. And the Upper Gunnison is important with regard to the Colorado River system because it is the second largest tributary to the system. And it is also the largest tributary to the Colorado River in Colorado. It's also important to talk about reservoir infrastructure. There are two federal reservoirs located in the Upper Gunnison watershed, specifically Blue Mesa Reservoir, which is a Colorado River storage project reservoir, and then Taylor Park Reservoir Dam, which is owned by the U.S. Bureau of Reclamations and operated by the Uncompahgre Valley Water Users Association. They have the first fill right, and then the Upper Gunnison District has the second fill right, and I'll tell you a little bit more about that in just a second. If you look at this map on the left, there are also 4 federal dams with hydropower units on them, and these are those black tick marks that you see there on the map. Specifically, I want to call out the 3 hydropower units in the Aspen, which are Blue Mesa Dam, Morrow Point, and then Crystal. And then the 4th hydropower unit that's being installed is currently underway at Taylor Park Dam. And that's the reservoir up on the upper part there. No, sorry, Beth. That's okay. With regard to reservoir operations and water rights, we wanted to tell you a little bit about the Taylor Park Reservoir 1975 Operation and Storage Exchange Agreement. And what this agreement basically did is it allowed us to stabilize flows on the Taylor and Gunnison rivers. It facilitated the management and exchange of water between Taylor Park Reservoir and Blue Mesa Reservoir. It also provided for flood control, supplemental irrigation uses, and allowed us to optimize the fishery and recreational conditions, both in the reservoirs and then on the Taylor and Gunnison rivers. That 1975 agreement also allowed that reservoir first fill to be exchanged downstream into Blue Mesa Reservoir when the Uncompahgre Valley Water Users Association didn't need it immediately. And then it also allowed us to take that second fill right, which is basically their surplus flows, and utilize it for the benefit of the Upper Gunnison District and our water users, both recreation, fishery, and then irrigation. Finally, the amended stipulation was really important because we had to reach an agreement with a private party water right owner who had an environmental in-stream flow right that he used for the fishery health. And it basically also required the Upper Gunnison District to facilitate a Taylor local users group that was composed of representatives from the community, including fishermen and fisherwomen, homeowners along the river, commercial boaters, flat water recreation, and then agricultural irrigators. That Tailored Local Users Group, or what we call TLUG, makes recommendations to the U.S. Bureau of Reclamation on how those tailored reservoir water supplies will be used. And then finally, there's the Aspinall Unit Record of Decision, which was really important in reoperating the Aspinall Unit, Blue Mesa, Morrow, and then Crystal in a way that would avoid a jeopardy opinion and jeopardy to downstream endangered river fish species. And that really represented an extraordinary effort by local water users to meet the goals of the Upper Colorado River Endangered Fish Recovery Program, to comply with constraints associated with flood control, to meet existing water rights and ensure that long-term sustainability of operations. And then finally, it has really important implications for Clean Water Act compliance and meeting selenium standards. And so with all of this, I'm telling you it because it has very important ASO data, and accurate water supply forecasts are very important for us to meet all of these agreements that I've identified here. And so finally, Beth's going to talk more about tools in our Upper Gunnison River Basin toolbox.
Good afternoon. Thank you for having us. ASO is just one of a number of tools in our toolbox that we use annually to forecast stream flow and reservoir inflow amounts, timing of snow melt, and a myriad of other water management aspects in the basin. We continue to advocate for its use because it is an incredibly useful tool with high accuracy. As highlighted, the available data has important economic impacts for our basin. The Upper Gunnison District has conducted 2 airborne snow observatory flights in the Taylor, East, and Upper Ohio Creek drainage basins. And these basins represent highest water producing basins in our district. And this has been ongoing for a number of years. Furthermore, we intend to use a localized Doppler gap weather radar station that will be installed near Blue Mesa Reservoir by October 2023. And this will help in planning ASO flight windows, provide additional information on precipitation, falling not only as snow, but rain as well, in our focus basins and across almost all of the Upper Gunnison watershed. And this supports ongoing research and also supports our cloud seeding efforts in the basin. This is an example, apart from as part of the ongoing modeling in the basin, this is an example of forecast products we have received from our association with Dave Gotchis and Warp Hydro. These graphs show the SWE analyses from SNODOS and from the Warp Hydro model with and without ASO assimilation, as well as basin integrated snowpack forecast for the spring runoff season. The top one is the Taylor Basin and the bottom one is the East River Basin. And the 2 red lines indicate the flight dates in 2023, which was April 1st and May 23rd. Wharf Hydro products also include snowpack analyses, runoff forecasts, reservoir inflow, and soil saturation. With these products, we have a more comprehensive picture of how water conditions vary from season to season. Here is another example of some of the Wharf Hydro output with ASO data assimilated. Shown here is a comparison in the East River Basin in the Upper Gunnison between this past water year, 2023, and the last year with high snowpack, which was 2019. ASO flew on or near April 1st in both years as the snowpack was at its peak, according to the snowtell stations. The snowtells indicated essentially equivalent SWE amounts in the basin both years. However, ASO data indicated that there was about 20,000 acre-feet more basin SWE content in 2019, which was about 5% more, with fairly large differences in the location of the SWE in the watershed, which has a strong impact on the timing of snow melt. This is the same comparison, but in the Taylor River Basin. According to ASO, the Taylor River Basin contained exactly the same SWE volumes in both years, with similar spatial pattern differences to the East River, and that included elevation, avalanche, and wind distribution. But the snowtell sites were telling us there was a substantial SWE volume difference between the years. If we had only used Snowtel, we might have overestimated our available water supply and planned poorly with regard to the Taylor Reservoir operational releases, which has a significant final impact on the community. We use, as part of our basic snowpack forecasting, we use a total of 5 Snowtel sites in the Upper Basin. The Snowtel data has much less information than what is received through ASO and warp hydro assimilation. The figure on the left is the April 1st Schofield Snowtel site, and which showed that there was about 47.5 inches of SWE. On the right, the ASO flight on 4-1 showed 368,000 acre feet of above 8,000 foot elevation, which is more detailed than what is provided at the Snowtel site. Flow values for the East River at Almont exhibit much greater influence through inclusion of ASO data, with the increase in medium flow on the order of 25%.
This slide that you guys see here represents the anticipated radar coverage from an Upper Gunnison Basin gap weather radar station, which is planned for installment in October, as Brett previously said. The white line that you see in the middle of this slide is where the current Grand Junction radar to the east is blocked by our mountains, and that results in poor weather forecasts for our area. You know, the benefits of using this gap weather radar sites, as Beverly said, include, you know, identifying those snow flight windows that we will need to know when doing flights here in the Upper Gunnison Basin, but it also provides information on wind shear. The ski area can predict with good accuracy when we're going to get good snow. And it's also really important for, you know, flight for life for our rural hospitals. You know, we wanted to highlight the importance of it also with regard to the location of Blue Mesa Reservoir and then Taylor Park Reservoir as well. And the extent of the coverage is important because it relates to the ability to further refine our snowpack data, our model forecasts, and then also just get that other part of precipitation falling as rain. It's also going to be important to our ability to tie our remote cloud seeding generators into these gap radar sites as well, which will help with regard to snowmaking.
This slide is dust on snow. Obviously, everybody knows what dust on snow looks like. The ASO data, this was done in 2022, and this clearly shows dust deposition on the snowpack in the East River Basin. This is a major factor affecting timing of snowmelt runoff in the Upper Gunnison Basin, and we have had some significant dust on snow events in our area over the past few years. This plays into our water management decisions and helps with early and faster runoff, has critical impacts on water availability and water management for our district, both during the spring and later in the summer and fall. The second photo shows an actual dust on snow event that occurred at approximately the same time. Additional ASO data provides us with more comprehensive picture of actual dust on snow events and the possible ramifications of these events.
So we talked to you a little bit about water management, endangered species compliance, but then we were going to highlight with the next few slides just some additional information on how we think ASO is of benefit to our community, including flood prevention, prediction and changes of hydrology associated with wildfire, the importance of it in terms of high mountain hydrologic research and model development, predicting annual hydropower generation, tourism and recreation, and then the environment, and of course, agricultural irrigation.
In the area of flood prevention, the Upper Gunnison District participated in local Gunnison County emergency flood planning meetings in 2023 for the first time due to the high snowpack that we had. And we were able to utilize ASO flights and WRF hydro forecasts to inform emergency response planners and our community that, contrary to what our Snowtel sites were saying, we had significant snowpack SWE remaining in the East River, and that runoff peak flows were not quite finished for the year. The hydrograph above clearly shows that we had multiple high flow events. The Upper Gunnison Basin is also currently experiencing our first significant wildfire. This is the Lowline Fire, and it's located in the Upper Ohio Creek Basin, where ASO flights have been flown. ASO data can provide important information around managing hydrologic changes in snowpack accumulation and the timing of snow melt post-wildfire. This image on the left, provided by ASO, shows pre- and post-fire LiDAR-derived canopy height models in the Upper Colorado Headwaters, which is the blue boundary. Oops, that picture is not in there. I'm sorry. We had a graph about the 2021 East Troublesome fire in there. And but in addition to capturing forest structure information and change, the ASO capacity to map SWE volumes, regardless of disturbance, removes a lot of the guesswork about how the snow accumulation and melt have changed in response to the fire. Let's see. Oh, there it is right there. So that's the graph that we wanted to show. This is the red boundary shows the LiDAR, and the blue boundary shows the East Troublesome fire. There are also significant scientific benefits from ASO data collection. In the Upper Gunnison watershed, we have Lawrence Berkeley National Laboratories carrying out important DOE research, including the SAIL studies on monitoring and predicting rain, snowfall, and water availability in the Upper Colorado River Basin. We also have the permanent presence of Rocky Mountain Biological Laboratories. And recently we were selected as the second focus area by the USGS Next Generation Water Observing System group for intensive data collection over the next 5 to 10 years in high mountain snowpack and water supply forecast modeling. And we feel that the ASO will contribute significantly to this. And these 4 photos show on this slide demonstrate the 4 hydropower sites in the Gunnison Basin that Sonja talked about previously. More accurate water supply information helps predict annual hydropower generation at Taylor Reservoir, Blue Mesa, Morrow Point, and Crystal. The hydropower system at Taylor Reservoir is not quite active yet. It is forecasted to be online in 2024. And tourism, of course, recreation and tourism in our area are great economic drivers in the basin. The increased accuracy of water supply information benefits ski areas, commercial boating industry, hotels, and the local economy as a whole.
ASO data is also important to our agricultural community. Other than Taylor Park Reservoir, we don't have an upstream reservoir to help with regard to management of that water supply. And so our water users depend on whatever Mother Nature gives them in any given year. And so, for instance, in very dry years, the agricultural producers might try to make greater use of those spring pulse flood flows to irrigate their fields and get their crops started, knowing that that water supply is going to decrease as we move throughout the season. In many of those dry years, those water users have to forego a fall application, and knowing that is really important to them in terms of what economic impacts they might see or how they have to manage their crop or their herd. In good water years, it means that those water users can put a fall application of water on those fields and put those fields to bed wet, as they say, so that come springtime, when that ground starts to melt, that water supply is there and it gets that crop going much quicker. So we do provide that information annually, and our water users, our agricultural water users, watch it very closely.
And finally, environmental flows are really important to our community. As mentioned previously, the Upper Gunnison District works with the TLUG to identify flows beneficial to our gold medal rated fishery, as well as our annual kokanee salmon run.
And so, yeah, with that, we're finished and happy to answer any questions from your group.
Thank you both so much. It was really great to see. Any questions for Sonja or Beverly? Everybody's asleep. Oh, Eli.
Hi, thanks for the great presentation. This is Eli. I was really interested to see what seemed like kind of a forecast-informed agriculture application. I think I've been seeing that more and more just emerging as a concept in the past, like maybe just a couple of years, at least of my reading. My question was on how that's communicated and any kind of quantitative metrics or dashboard or anything that you all have found is useful for individual irrigators to make, headgate level decisions based on something that's fairly far removed from headgates like a SWE map.
So I would say that our local water users, they get a lot of information through the TLUG and through our agricultural irrigator, our representative. That member is also a member of the Gunnison County Stock Growers, where they do share information regularly about that. Our water users are also know where to find SNOTEL data on the NRCS website and others. And then it's also communicated through the Upper Gunnison River District board and the work that we do. So there's various ways that we get that information out, but I think they know a lot from year to year on whether that snow is falling at lower elevations and they have issues with calving and things like that, or whether it might be following at those higher stations. And so we do relay the ASO data back to them.
Sonja, there we go, sorry. With the two basins that we've been flying for you guys, the Taylor and the East, obviously there's storage in the Taylor, but not in the East River. Does that affect, how the information is of utility in those two basins, or is it kind of the same thing, but you just have a knob to turn in one of them?
No, yeah, thanks for the question. It is really important. So the East River and the Taylor River combine in Almont to form the Gunnison River. So when we're operating Taylor Park Reservoir, we have to be careful to watch whatever snow, what flow is coming down in the East River, or what amount of snowpack we have there, because we don't want to flood lower Gunnison homeowners along the river. So that is really important. And then what was I going to say? Yeah, sorry, in addition, I'll think of it in a minute. I'm sorry, Jeff.
No problem, yep.
Yeah, so the two rivers and flooding, the timing. And so, yeah, I know what the second thing was. So there was so much snow up in the Taylor Park Reservoir this year. We actually did some early releases in late April, early May, which we typically don't do. We usually start releases probably that third week of May. But we knew that there was going to be so much water, we didn't want to have the reservoir spilling. And so we started to increase flows. But one of the other things we were also watching is that we often get ice jams on the river. And so we didn't want to release flows from Taylor Park and accidentally cause those ice jams to dislodge and move downstream and destroy bridges or other infrastructure. So it's this fine little dance that we have to do, but knowing that additional snow was up there and having that accurate forecast allowed us, to manage that water properly. If we hadn't had it, we had relied on SNOTEL, that reservoir would have been spilling. Mm-hmm. And again, they're going to be putting hydropower on it, so that's definitely not something that you want to be doing when you go through the expense of installing hydropower.
You don't want to bypass that brand new turbine.
Exactly right.
I had a question, and then you conjured the image of dam spilling in my mind, and I lost it.
Oh, sorry. It's probably my fault.
Here's another question for you.
Okay.
You guys mentioned that you have the gap radar and that it's one of your tools. I'm curious how you're using that, if you are directly, or is it through other providers of information that are using it?
So again, it hasn't been installed yet, but when it is installed, it's going to be installed by the Western Water and Weather Intelligence Center. And so it's going to be, it's a nonprofit, and they're utilizing some funds to help install these gap weather radar sites throughout the West. I think they have 4 planned in Utah and maybe 3 in Wyoming. But, you know, what we did was enter into a memorandum of agreement with W3IC that would allow our researchers to access that data in a timely fashion. And so hopefully that answers your question.
I remember what I was going to say. You gave a shout out to all the basic research going on in the basin, led by the Lawrence Berkeley Lab crew. Do want to give them a shout out as being a regular funder of the ASO program in the basin, and it's really, it's been cool as an ex-Valley resident myself. Really cool to see all of the convergence of everything from basic research to actual, you know, operations support for these data and other ones just in the Upper Gunnison. And also you mentioned the fire response. And I wonder if you know the current status of the Forest Service plans in Lotus Creek to do some forest treatment work and prescribe burning up there. I know Ken Williams at Berkeley Lab Group was really keen to get us flying in Lotus Creek in order to get that pre-treatment state documented, both from the forest structure as well as the several years of snow accumulation, and then to have that background available for when the forest does their treatment plans. Do you know any updates on those plans?
I don't have any updates, but I do know that they're moving forward. All of the NEPA compliance has been completed, and yeah, I'm really interested in how that forest management, whether it be the way you clear a forest, whether it's patchwork or whether it's, you know, clearing in areas where you have significant beetle kill and just getting everything down, and the impacts on hydrology, the timing of hydrology, snow albedo, and then also just water quality impacts as well. And so I think, you know, those changes pre and post utilizing ASO data is going to be really interesting to look at.
Awesome. Well, great natural laboratory going on, as well as some real-time operations. It's really cool to see. Oh, Dave says that they're doing the site survey for that Lotus Creek treatments on Friday.
Oh, great.
All right. Well, thank you so much, Sonja and Bev. Really appreciate the presentation. Thanks for being part of the Colorado sessions here this afternoon.
Great. I hope you guys have a great day.
All right, that I think wraps up our session here. I didn't look at the calendar. What's up next? Oh, break and then poster session / drink tickets.